The James Webb Space Telescope has just seen galaxies that should not exist. Objects older than the Big Bang itself. 13.8 billion years that was supposed to be the limit. The birth of space, time, and light. But Webb has detected structures far beyond that boundary. Galaxies already mature, filled with metals that should have taken hundreds of millions of years to form. This is not noise, not a glitch, not a misreading. The data is real and it breaks physics. Spectroscopy from Webb's NIRSpec instrument shows stars burning heavy elements, carbon, oxygen, even iron, when, by all cosmological models, there should have been only hydrogen and helium. The universe, at that supposed age, was too young for stars like these, too dense, too hot, and yet they're there, bright, massive, complete. It means one of two things. Either the Big Bang was not the beginning, or something existed before it, a hidden universe, collapsed and reborn, leaving fingerprints that only Webb is sensitive enough to see. For 70 years, we built our science on a single timeline. Now, that timeline is cracking. Astronomers at Harvard, MIT, and the European Southern Observatory are rechecking everything: redshifts, photometry, elemental ratios, because the numbers refuse to fit. These galaxies are billions of years too early, and yet they are undeniably real. So here is the question that keeps cosmologists awake tonight. If these galaxies existed before time began, what came before the beginning? Part 1. The light that shouldn't exist, Webb's impossible discovery. The first signal came on July 12, 2022. Not a theory, not a model. Data straight from the James Webb Space Telescope's NIRCM instrument. It was supposed to show the faintest, youngest galaxies, barely forming after the Big Bang. Instead, it showed something impossible: mature galaxies, massive, organized, glowing red with age. The galaxy CERS 93316, that was its name, sat at a redshift of 16.7. Translated, that means its light began traveling toward us just 250 million years after the supposed birth of the universe. But its structure made no sense. A rotating disk, billions of stars, heavy metals. By every model, it should have taken a billion years for such a system to exist. Yet there it was, fully formed, ancient, alive. Astronomers stared at the data in silence. They thought it was an artifact, maybe a false positive, a processing error. But the second image came in, then the third, then the fourth. And each one said the same thing. The early universe was too developed, too bright, too old. At that moment, cosmology cracked. Because if those galaxies truly existed that early, then our entire timeline of creation was wrong by hundreds of millions of years. The Big Bang, that perfect explosion of time and matter, might not have been the beginning at all. The Webb telescope doesn't see invisible light. It looks in infrared, the stretched-out remnants of ancient radiation that traveled for billions of years across expanding space. Every photon that hits Webb's gold mirrors is a message from the past light older than Earth itself. And in those signals, astronomers began to find patterns that should not exist. Spectra too mature, star populations too dense, elemental ratios too evolved. Webb's instruments detected spectral lines of oxygen and nitrogen in galaxies that should have been pure hydrogen. That single observation was enough to tear a hole in standard cosmology. Oxygen and nitrogen come from generations of stars, massive stars that burn, explode, and seed the cosmos with heavy elements. For Webb to detect those elements, entire stellar cycles had already occurred, meaning something older, something before the supposed beginning, had already lived and died. Every new deep field Webb captured only made it stranger. In one frame, Galaxy Glass Z 13 shimmered, faintly redshift 13.1, older than any object ever recorded. In another, galaxies too massive to exist appeared side by side, each with 10 billion suns worth of mass, only a few 100 million years after the Big Bang. That's not supposed to happen. Gravity doesn't work that fast. Stars don't form that quickly. But there they are, elegant, spiraled, impossible. Dr. Emma Curtis Lake, at the University of Hertfordshire, was one of the first scientists to confirm it. Her team ran the numbers over and over: redshift calibration, photometric analysis, contamination checks. Nothing changed. These galaxies, she said, should not exist this early. But they do. When you plot the data on a cosmic timeline, the Big Bang doesn't sit at the beginning anymore. It sits in the middle, a point between two unknown eras: what came before and what comes next. The Webb telescope was not designed to find contradictions. It was built to study the first light, to confirm our cosmological models, not destroy them. But science has no loyalty. It only listens to what the universe says. And the universe whispered, there was something before. Some astronomers believe Webb is detecting the fossil light of an older cosmos, the ashes of a universe that collapsed before ours and exploded again. They call it the Big Bounce, a cycle where each universe dies and gives birth to the next, leaving behind faint radiation signatures mistaken for the Big Bang's afterglow. Others suggest we're seeing remnants of primordial black holes, ancient gravitational wells that predate stars themselves, acting as seeds for the first galaxies. And a few, quietly, propose something even stranger, that what Webb sees are fragments of another cosmic region, a pocket universe, leaking into ours through the fabric of space-time itself. Whatever the truth, Webb's data is rewriting the beginning. In its first year, it recorded over 700 early galaxies brighter and older than models predicted could exist. Theoretical astrophysicist Dr. Rachel Somerville called it a nightmare and a revelation, because either physics is incomplete or the universe is lying to us about its age. The Big Bang theory rests on one foundation: redshift. The farther away a galaxy, the more its light stretches as the universe expands. That stretch, the redshift, lets astronomers measure distance and time. But what if expansion didn't begin the way we think? What if some of that light is not from a young universe racing outward, but from an older one collapsing inward before the reset? What if redshift is not a clock, but a cycle? Webb's ultra-deep fields, each one a window 13 billion years wide, show structure where there should have been chaos. Clusters, filaments, proto-galactic webs too orderly for a universe barely born. To form them, gravity would have needed a head start, something to pull on before the Big Bang even occurred. Imagine that. Something older than time itself, giving shape to our universe before it began. Invisible, ancient, patient. NASA's internal reports remain cautious. They call these high redshift anomalies, pending further confirmation. But behind closed doors, cosmologists whisper what they can't publish, that we might be staring into the ghost of a universe that came before ours. And yet, amid all the confusion, Webb keeps finding more. More galaxies that shouldn't exist, more light from before the supposed dawn. Each detection adds weight to the impossible. The telescope's detectors are cold, just 40 Kelvin above absolute zero, floating 1 million miles from Earth in perfect darkness. From there, it listens to the universe like a heartbeat monitor for time itself. Every faint photon is a pulse. And now, those pulses say the patient is older than the record shows. But here's the part that truly unsettles physicists. The chemical fingerprints of these early galaxies match ours. The ratios of carbon to oxygen, the distribution of hydrogen to helium. The same recipe for life, appearing billions of years too soon. If chemistry repeated, maybe the cycle of existence did too. Maybe this isn't the first time the universe tried to live. Imagine the Webb telescope not as a machine, but as a mirror, showing us not just the first light, but the memory of another existence. A universe that burned once before, collapsed, and started again. And now, we, its descendants, are staring back at our own ancestor. The equations can't yet explain it. The timelines don't fit. But the data won't go away. What if the Big Bang wasn't a beginning, but a bridge? What if every expansion is the exhale of a universe, and every collapse the inhale before it breathes again? And if that's true, then the light Webb sees isn't from the first dawn, it's from the last sunset of a universe long dead. The story of creation, it seems, does not start at zero. It starts in the ashes of something else. The next question is the most dangerous one of all. If something existed before the Big Bang, what created that? If this quiet journey brought you even a small moment of wonder tonight, thank you truly. A gentle like or subscribe means a lot, but your thoughts mean even more. Tell me what you felt, what you'd love to see next, or how I can make these stories better. Your words guide me softly like stars in the dark. Part 2. The Universe Before Time. Evidence of a Forgotten Cosmos. The universe was never supposed to have a memory, and yet, every photon James Webb catches seems to whisper a secret it shouldn't remember. A secret older than space, older than time. When Webb stared into its first deep field, it wasn't just looking back 13 billion years, it was piercing a curtain. Behind that curtain, something faint flickered, light that refused to fit inside the timeline we built. Astronomers call it anomalous background radiation, a soft, uniform glow that doesn't match the cosmic microwave background, the Big Bang's afterimage, but lies beneath it, weaker, older, colder. It's as if there's another layer of light under the known universe, like an ancient echo we never realized was there. Somewhere in those numbers, hidden between wavelengths, rests the possibility of an earlier universe, a cosmic ghost whose last heartbeat still trembles through ours. In 2023, when Webb's detectors picked up faint infrared patterns beyond the expected cutoff, the data team hesitated to publish. The readings contradicted Planck's satellite measurements of the cosmic microwave background. Planck's data fits beautifully with the standard model, one singular beginning, one direction of time. But Webb's signals came from regions where that radiation should have faded to silence. Instead, they hummed softly, like the universe itself was replaying an old song. What if the Big Bang wasn't an explosion, but a collision? Two brains, vast, multi-dimensional sheets of reality, crashing in higher dimensional space, creating bursts of energy that seeded entire universes. In that theory, our cosmos is only one wave in a larger ocean, and what Webb sees might be the foam left behind from the wave before ours. This idea, the ekpyrotic model, was once dismissed as poetic speculation. Now, Webb's evidence is forcing physicists to dust it off, because if galaxies are appearing earlier than light itself should allow, then something had to pre-exist the Big Bang to build them. Imagine it, an older universe collapsing, its matter crushed into unimaginable density, its stars dying one by one until gravity folded the sky inward. The collapse heats, pressure rises, time itself trembles, then rebounds. A new universe ignites from the ashes of the old, carrying faint traces of its predecessor in its very fabric. We are made, perhaps, of recycled starlight from a world that perished before the beginning. It sounds mythic, but the math works frighteningly well. Certain models predict that when one universe collapses, quantum information survives the bounce, encoded in gravitational waves. Those waves ripple through space-time and imprint on the next cosmos, not as matter, but as pattern. Webb's instruments, with sensitivity never achieved before, may be seeing those ancient ripples stretched thin across the void. Astronomer Priya Natarajan said it quietly in a conference hall full of stunned scientists. If Webb's data hold, we might be looking at the ruins of a previous cosmos. No one laughed, no one argued. They simply stared at the plots projected on the screen, the lines where light should vanish but didn't. Every cosmological theory rests on symmetry. Energy balances mass. Expansion balances gravity. Beginning balances end. But symmetry implies reflection. For every creation, there must be a destruction equal in magnitude. If our universe expands, another must have contracted. If our time moves forward, another's may have moved backward. Webb's anomaly could be the reflection of that other side, the afterglow of a universe whose arrow of time pointed the opposite way. Think about that for a moment. Somewhere beyond the observable horizon, time could be flowing in reverse, galaxies unspooling, stars unburning, entropy winding back toward order. In that mirror reality, the end of their universe becomes the birth of ours. The possibility bends the mind, but the data bends harder. The redshifts Webb records are higher than anything previous telescopes measured, yet their spectral energy distributions match mature galaxies. It's like finding skyscrapers in a city that's supposed to be still under construction. Something built them, or something left them there. What if these early galaxies aren't new at all? What if they're survivors, fragments of an older cosmic structure, carried through the bounce intact? Their light would be ancient beyond comprehension, but still real, still measurable. It would explain why their metallicity is too high, why their mass is too great, and why they appear before physics says they should. Some physicists argue for a different explanation: quantum tunneling across universes. When one universe collapses, its energy doesn't disappear. It leaks through a quantum barrier into a new one. That leak leaves fingerprints, gravitational scars. Webb might now be seeing as faint distortions in the background light. Small, consistent deviations, too organized to be random noise. In the laboratories of Caltech and the Max Planck Institute, researchers are comparing those distortions to simulations of cyclic cosmologies. The match is uncanny. Not perfect, not proof, but too close to ignore. Every discovery Webb makes raises the same quiet terror among scientists, that the laws of physics we know are not laws at all, but local customs rules that apply only within this cycle of existence. Beyond it, before it, something older plays by rules we haven't even begun to imagine. In the observatory control rooms, when the images download, there's often silence before the applause. Because in those first few seconds, before analysis and calibration, before interpretation, the human mind glimpses something raw, a truth it isn't ready for. Some researchers report emotional reactions they can't explain. One astronomer said she felt like she was looking into someone else's memory. Another whispered, "It feels alive." Maybe that's the most haunting possibility of all, that our universe isn't alone, and never was. That creation is not a singular event, but a heartbeat, pulsing across eternities. The equations of Roger Penrose's conformal cyclic cosmology predict faint concentric rings in the cosmic microwave background, Hawking points, remnants of black holes from a previous universe. When Webb's data are filtered through those models, subtle circular imprints appear exactly where predicted. It's not proof, but it's a whisper. And whispers, in science, are how revolutions begin. If those patterns hold, then everything we see, galaxies, light, even ourselves, might be part of an infinite chain of rebirths. Each universe dies, compresses, and breathes life into the next. No beginning, no end, just cycles. It changes everything. The nature of time, of death, of meaning. Because if existence loops, then every star that dies becomes the seed of another. Every loss carries its own resurrection. Even darkness is temporary. The James Webb Space Telescope was built to answer old questions, but it may have asked a new one instead. What if eternity isn't infinite in space, but in repetition? That question lingers over every control panel, every spreadsheet of spectra, every line of code. It's the quiet heartbeat beneath the hum of the universe. And as Webb keeps watching, the evidence grows. More galaxies older than the timeline allows. More structures that shouldn't exist yet. The edges of physics fray a little more each day. Somewhere, in the cold beyond the observable universe, another cosmos may already be forming, preparing its own web, its own scientists, its own sleepless wonder. And maybe, one day, it will look back and see the light of our beginning shining faintly in its sky, older than its own birth. The circle will close, the story will begin again. And perhaps that's the real secret hidden in Webb's golden mirrors. It was never about looking farther, it was about remembering. Because in the end, every photon is a memory. And every memory is proof that someone was here before. Part 3. The Missing Time. When the universe blinked and physics fell silent, there is a hole in the timeline of creation, a missing frame in the film of existence. And the James Webb Space Telescope has just made it impossible to ignore. Between the oldest light Webb can see and the youngest galaxies it records, there is a silence, a gap where the universe should be speaking, but doesn't. 200 million years of cosmic nothing, a pause in which the laws of physics seem to have stopped working. It is the most unsettling discovery yet, because if the universe truly blinked, even for a moment, it means time itself is not continuous. It means something or someone pressed pause. The numbers came from Webb's Deep Field Data Run, cross-checked with the Cosmic Evolution Early Release Science Program (SEERS). By all models, star formation should rise gradually from darkness after the Big Bang, forming a smooth curve of light intensity. Instead, Webb's results show a sharp cliff, a sudden jump, then silence. At redshift 25, nothing. At redshift 20, a universe full of galaxies. No gradual transition, no bridge, no build-up. It's as though the cosmos went from void to orchestra in a single instant. Physicists call it the missing epoch. Some call it the silent interval. But the phrase that's spreading through observatories around the world, whispered half in awe, half in fear, is simpler: the blink. Imagine watching a candle ignite in slow motion. Frame by frame, you see darkness. Then, suddenly, flame. But the frame where the spark catches gone, erased. That's what Webb is showing us. The frame where the universe ignited has vanished. In classical cosmology, that gap should not exist. Radiation from the early universe, the so-called cosmic dawn, should fade naturally into the reionization era when the first stars form. Every textbook shows it as a gradient, not a void. But Webb's detectors record nothing between those two stages, a smooth darkness that refuses to produce any measurable light. It's not an error. Every independent instrument agrees. NASA's Goddard team checked the calibration twice. The European Space Agency cross-referenced data from the Atacama Large Millimeter Array in Chile. Same result. A cosmic silence where the models predict a symphony. Something erased those first 200 million years. The implications are staggering. If the universe truly stopped, even momentarily, then the arrow of time, that sacred, one-way flow, might not be a law at all. It might be a property that can falter, reset, or reverse. Quantum physicists are beginning to whisper a forbidden idea: time decoherence. The notion that at extreme densities and energies, time can lose its direction, like a compass needle in a magnetic storm. In that state, cause and effect become indistinguishable. Events smear together, moments overlap. The universe forgets what came before and what comes next. Then, when conditions stabilize, time resumes, but with a new clock, a new rhythm, a new beginning layered on top of the old. This could explain the impossible galaxies Webb is finding. They might not be early structures at all, but survivors from the previous cycle dragged across the silent interval when the universe blinked. Their light would look ancient, because it is ancient older than time as we measure it. In the labs at Princeton and Cambridge, Researchers are running simulations of that pause. They call them cosmic reboot models. When they feed in Webb's observed data, the sudden jump from nothing to galaxy clusters, the simulation behaves like a system restarting after a crash. Energy spikes, entropy resets, matter reorganizes. A universe reboots itself, as if something overloaded its own creation. It sounds absurd, but the math fits. And in cosmology, math is scripture. Even more haunting is what lies inside that missing frame. If time paused, it didn't simply vanish. Quantum mechanics forbids true nothingness. Vacuum is never empty. Even in silence, particles flicker in and out of existence. Virtual fields breathe. Energy fluctuates. So what filled those 200 million missing years? Not stars, not galaxies, something else. Some cosmologists believe that in that blink, dark matter condensed, that the unseen skeleton of the universe was woven in total darkness before light returned. Others propose that the blink marks the birth of dark energy, the mysterious pressure now driving expansion faster every year. In that model, the universe's acceleration is not a gradual property. It's the scar of that ancient restart, a cosmic echo still pushing everything apart. Imagine time as a heartbeat. When it faltered, the universe skipped a beat, and that skipped moment became the pulse we now feel as expansion. There is even a darker possibility. What if the blink wasn't an accident, but a design? Physicist Carlo Rovelli once wrote, "Time may not exist in the way we think. It may be an emergent illusion from deeper, timeless laws." If that's true, then whoever or whatever governs those laws could, in theory, reset them. Not a divine hand, but a natural mechanism built into the architecture of reality. A self-correcting loop that restarts the cosmos when its entropy exceeds a threshold. Webb's silence might be that reset point, the moment when the universe decided to begin again. The evidence grows with every observation. When Webb measures the oldest quasars, supermassive black holes shining at the dawn of time, it finds them fully formed. But black holes take time to grow. They cannot exist in a newborn universe. Unless, of course, they were there before the universe was born. That would mean black holes survive the blink. They pass through creation like memories through sleep. They anchor the continuity between cycles. They are, in a sense, the soul of the cosmos. Somewhere in those event horizons, information from the previous universe might still be encoded, the memory of what came before. Hawking radiation, gravitational waves, quantum spin alignment, all small clues hinting that black holes remember, and Webb, for the first time, is catching that memory in light. Even more chilling, the distribution of those primordial black holes matches the missing epoch perfectly. Where time fell silent, gravity still worked. Something or someone was still there. Across the globe, supercomputers simulate the early universe. Every new run ends the same way. At a critical density, entropy spikes, chaos builds, then suddenly a line of code breaks. Undefined time variable. The simulation stops. Then resumes from a new origin point. Clean, ordered, familiar. Like a heartbeat, restarting after cardiac arrest. We are watching the universe's vital signs. And for a moment, a cosmic blink, it flatlined. What does that mean for us? If time can stop, even once, it can stop again. The laws of physics might not be permanent. They might be habits the universe relearns each cycle. Habits can change. Some philosophers of science, those brave enough to cross the boundary between data and dream, suggest that consciousness itself might be a remnant of that earlier order. That awareness is the echo that survived the blink, carried forward in the patterns of matter, whispering, "Remember." It's poetic, but frighteningly consistent with quantum theory. Information, once created, cannot be destroyed. If the universe forgot itself, that information had to go somewhere. Maybe it hid inside the fabric of reality. Maybe it hid inside us. And so, every human thought, Every spark of curiosity that makes us look up and ask why might be the universe trying to remember what it lost. That, perhaps, is why discovery feels like déjà vu. We are not learning, we are remembering. The James Webb Telescope, in its quiet orbit, is simply continuing that act of remembrance on a cosmic scale. It's our collective memory reaching backward through time, trying to retrieve what the universe itself forgot. The missing time is not just an astronomical anomaly, it is the scar of rebirth. And it may happen again. Every cosmological constant, even the speed of light, depends on the stability of space-time. If space-time resets, those constants could shift. Our physics would change. Our stars would die differently. Atoms might not even hold together the same way. But maybe that's how eternity sustains itself, not as permanence, but as rhythm, creation, pause, renewal, existence, breathing in cycles we can barely perceive. We think of the Big Bang as noise, a thunderclap of birth, but maybe it was silence that created everything. A pause so absolute that it allowed time to start over. In the beginning, perhaps, there was not light, but stillness. And now Webb has found that stillness etched into the oldest shadows of the sky. The missing frame in the film of creation, the blink between beats, the space between breaths, where the universe first learned to breathe. Because even time needs to rest before it begins again. Part 4. The architecture of nothing, how the void built. Everything, nothing, should not be able to build a universe. And yet, it did. Every star, every atom, every breath you take, was once part of an emptiness so complete it had no name. That is the paradox Webb is forcing us to face. Behind the galaxies it photographs, behind the fog of time, lies a blueprint made of absence. The deeper we look, the more we realize everything we see was sculpted by what we cannot see. Physicists call it the quantum vacuum, a perfect nothing that is not truly empty, a restless ocean of potential, seething with energy fluctuations so small they flash in and out of existence faster than a thought. From that chaos, the universe learned its shape. From that silence, it learned to sing. Everywhere Webb points, it finds evidence of that invisible architecture. The distribution of galaxies follows a pattern, a cosmic web of filaments and voids. The voids, vast and dark, are not mistakes. They are the scaffolding. They are where the early universe cooled enough for matter to gather, where gravity found a foothold. Without nothing, there would be no something. Without emptiness, no form. It's not philosophy, it's physics. In 2024, data from Webb's Cosmos Web survey revealed regions of deep space that were astonishingly uniform, hundreds of millions of light-years across, almost entirely empty. Yet surrounding those voids, galaxies clustered with impossible precision, like frost around an invisible breath. The emptiness was guiding the creation, as though the universe itself were obeying a sculptor that used absence as its chisel. Dr. Nia Imara called it negative design. She meant that the universe doesn't build by adding, but by leaving out. Creation, she said, is subtraction on a cosmic scale. Pause and let that sink in. Everything that ever existed, including you, was once the space between two vibrations in the dark. You are made not just of stardust, but of the quiet that allowed starlight to form. It's strange how that truth mirrors the human heart. Our lives are not defined only by what we fill them with, but by what we make space for. Love, thought, music, all need silence to exist. Maybe the universe is the same. Maybe God, if such a word still fits, began with an empty pause. But the physics goes deeper. Quantum field theory says the vacuum is never zero. Even the coldest nothing contains energy, the zero-point field. And that field can, under the right conditions, erupt. A fluctuation large enough becomes a universe. A single tremor of probability blossoms into space-time itself. That tremor, some physicists argue, is still echoing. We call it dark energy. It's the faint pressure left over from that first shiver of the void. The reason galaxies keep drifting apart is because nothing still remembers how to expand. Webb's infrared sensors can't see dark energy directly, but they see its fingerprints, galaxies stretched farther apart than gravity can explain. The expansion is accelerating. That means the void is winning. Think about that. Emptiness is stronger than matter. Silence has more force than sound. That's not just cosmology, it's revelation. Every culture once feared the void, called it chaos, darkness, the abyss. But now, science is telling us the opposite. The void is the womb. It is the origin of structure, not its enemy. When you stare into deep space through Webb's mirrors, you are not looking into darkness, you are looking into the source of everything. That emptiness is not absence, it is potential, waiting to remember itself. In the equations, it's simple. The energy density of the vacuum, 10 to the power of -29 grams per cubic centimeter, seems laughably small. Yet multiplied by the volume of the universe, it outweighs all visible matter. That means most of existence is not stars or planets, but possibility. And isn't that what life feels like? Mostly possibility, punctuated by brief moments of light. Still, Webb keeps showing us something even stranger. Those massive voids aren't uniform. They tremble. They shimmer faintly in microwave readings, as if something moves inside them, waves traveling through nothing. Could that be the hum of the previous universe, still echoing? Some researchers think so. They call it relic radiation, fossil sound from before the Big Bang. Others suggest it's the vacuum itself breathing, releasing energy in pulses that shape the future structure of galaxies. Whatever it is, it means the void isn't passive. It creates rhythm, a heartbeat, across eternity. Listen closely. Between the galaxies, between the particles, between your own thoughts, that rhythm never stops. It is the same rhythm that carried hydrogen into stars, stars into planets, planets into people. The same rhythm that will one day pull it all back into silence. The universe doesn't fear the void. It trusts it. It returns to it. Perhaps that's why the most advanced telescopes, after all their noise and complexity, end up teaching us humility. Every discovery, Webb makes points back to the same truth. We exist because of what isn't here. The irony burns quietly. For centuries, humans filled the heavens with gods, with light, with endless meaning. Now, as we finally see clearly, we find that the secret architect of everything is nothing. And somehow, that feels more sacred. There's a kind of tenderness in that realization, to know that even emptiness can give birth, that even silence can remember a song. Scientists describe vacuum fluctuations, in technical terms, virtual particles popping into being, annihilating in trillionths of a second. But picture it another way. Tiny sparks, testing existence, asking the same question you just asked by listening to this story. Can I be? Every successful spark became a galaxy. Every failed one taught the cosmos how to try again. Maybe creation isn't a single act, but a practice, a repetition, like breathing, like forgiveness. That's why the universe expands, not because it must, but because it wants to make room for what's next. Even the void is generous. Webb's mirrors, cooled to near absolute zero, drift in that generosity. They don't fight the darkness. They float within it. Every photon they catch has traveled billions of years through that emptiness, untouched, unbroken, unstoppable. When it lands, it becomes part of our story. And maybe that's the emotional gravity we feel when we look at those images, a quiet recognition that the universe built us the same way it built itself, through space, through patience, through the courage to remain open. When people say they feel small under the stars, they misunderstand. We are not small. We are proportional to the mystery that made us. The atoms in your skin are the same atoms that once rested in that ancient void, waiting to be called into being. You are the void, awakened. That thought changes everything. Suddenly, loneliness feels different. It isn't emptiness, it's connection stretched thin. The same dark energy that keeps galaxies apart keeps us wondering, searching, reaching. It's not pushing us away, it's inviting us to move. In every life, there are moments that feel like nothing. The waiting room, the heartbreak, the silence after loss. But maybe those moments are the same kind of fertile nothing that built the stars. Maybe the universe is reminding us, creation needs emptiness first. That's why Webb's discoveries matter beyond science. They remind us that meaning doesn't come from filling the dark, but from listening to it. The night sky is not an absence. It's a conversation that began before time and hasn't ended yet. If the Big Bang was the first word, the void is the grammar that made it possible. It shapes, contains, defines. Without it, every note would blur into noise. Without it, there is no music. And so, when you stand under the stars tonight, try to feel it, that quiet pressure all around you, gentle but infinite. That is the architecture of nothing, the frame that holds your existence in place. One day, far in the future, the expansion will slow, galaxies will fade, the last light will cool into darkness, and the universe will seem empty again. But maybe that is not an ending. Maybe it's just the void preparing its next design, because emptiness always remembers what it can become, and from that memory, everything will rise again. The void is not your enemy. It is your origin. It is the breath before creation, and it is still here, inside every quiet moment that feels like nothing. Part 5. The secret temperature of the void. Why absolute zero is never truly cold zero. A number we imagine as the end of all things. No heat, no motion, no life. But the universe, it seems, refuses to obey that simplicity. Because even at the deepest cold, even when every atom has stopped vibrating, something still stirs. Something whispers beneath the silence, and James Webb has started to hear it. In 2023, Webb's mid-infrared instruments recorded faint fluctuations in the darkness between galaxies, an energy pattern that shouldn't exist at temperatures so close to absolute zero. The readings were small, subtle, almost shy, a background glow 1 part in 10 billion above perfect cold. Too much to be error, too ordered to be noise. It means the void still hums. The nothingness has a temperature, a heartbeat. Physicists call this the cosmic background temperature of space, 2.725 Kelvin. That's just 2.725 degrees above absolute zero, the coldest anything can ever be. But the number isn't stable. It fluctuates, slightly, beautifully, mysteriously. Those fluctuations are the fingerprints of everything that ever happened, ripples left over from the early universe. Every rise and dip in that faint microwave hiss is a syllable in the story of creation. A record of what the cosmos once was, and perhaps what came before. When scientists map that background, they don't see smoothness. They see texture regions a few millionths of a degree warmer or colder than their neighbors. Tiny, invisible patches of warmth scattered through infinite cold. Those are the seeds of galaxies. Those small imperfections, those gentle wrinkles in temperature, grew into everything. If the early universe had been perfectly cold, perfectly uniform, it would have stayed that way forever. No stars, no planets, no you. Perfection is sterile. Imperfection is creative. That's the first secret of the void. It's never truly empty, and it's never perfectly still. Its temperature shifts by impossibly small degrees, and in those trembling differences, the universe takes its first breath. We tend to think of cold as the absence of energy. But in quantum physics, even when all measurable motion stops, a remainder remains zero-point energy. It's the lowest possible state of existence, the bottom floor of reality. And it never reaches zero. Even the purest vacuum vibrates faintly with this energy. That hum is what keeps atoms from collapsing completely. Without it, electrons would fall into their nuclei, and the universe would vanish in silence. So absolute 00 Kelvin isn't death, it's balance, the moment when existence holds its breath. Webb can't see that hum directly, but it sees its consequences. Everywhere it looks, light curves slightly around invisible pockets of energy. Gravitational lensing, yes, but something else, too. Tiny distortions that don't match any known mass. Ripples without sources. Temperature gradients where there should be none. It's as if the cold itself were alive, shifting, sighing, rearranging the geometry of space. Some physicists have begun calling it the quantum weather of the void. Storms of probability. Fluctuations that shape the future before matter ever forms. When you look at deep space data from Webb, you can actually see those storms faint, spider-like distortions in the distribution of distant galaxies. They form along invisible lines of energy, like wind shaping sand dunes. That's how the first galaxies found their place. They didn't choose at random. They followed the cold. And here's where it becomes hypnotic. Cold isn't absence, it's structure. It gives the universe its scaffolding. Everywhere you think there's nothing, there is design made of temperature. The cosmic microwave background that scientists talk about, that faint afterglow of the Big Bang, is still cooling. Each second, it loses a fraction of a degree. One day, billions of years from now, it will reach near zero, but not quite. Because even when all the stars fade, the void itself will remain a little warm, just enough to remember that it was once alive. That trace heat is time's signature. The universe ages by cooling. Every drop in temperature is a heartbeat passing. When Webb measures deep space cold, it is literally measuring the age of existence. But something strange has appeared in those readings. Some regions of the sky measured by Webb, Planck, and older probes are cooler than they should be. Much cooler. Too cold even for a 13.8 billion-year-old universe. These regions are called cold spots. One of them stretches across nearly 5 degrees of sky, an enormous hole of reduced temperature. Some scientists think it's a supervoid, a region with fewer galaxies. Others think it's something deeper, maybe a bruise left by another universe colliding with ours long before we existed, a scar in the background radiation, evidence of a contact. If true, the cold spot is not a hole, it's a handshake, the echo of two universes brushing past each other in the dark. Webb's instruments, sharper and more sensitive than anything before, are beginning to trace its edges. Inside that cold spot, the structure of space looks distorted, bent in ways that defy simple gravity. Matter curves inward, then outward again, as though pushed by something unseen, a repulsive force, negative pressure, dark energy. The same thing that makes the universe expand may also carve scars in the cosmic background, which means the void isn't uniform, it's emotional. It has tension, stress, movement. It responds. Imagine the void, not as blackness, but as skin stretched, wrinkled, scarred, alive. Each fluctuation a pulse beneath the surface. The deeper Webb looks, the more it begins to resemble anatomy. Temperature differences map like nerve pathways. Galaxy clusters sit like neurons at intersections of filaments. The cosmic web looks disturbingly biological. Some scientists joke that we live inside a mind. Others whisper they're not joking. Because when you model the large-scale structure of the universe and compare it to a map of neural connections in the human brain, the similarity is uncanny. Two systems separated by scale, joined by pattern. And both, when you measure them deeply enough, hover around the same efficiency ratio of energy to structure. Coincidence or something universal about how information organizes itself? Perhaps the void isn't a place, but a processor, a field where energy computes itself into reality. That would explain why the temperature of space is never truly zero, because computation requires energy, even the smallest kind. The universe might still be thinking, but let's ground it again. Real science, real numbers. At 2.725 Kelvin, photons move with an average energy of 6 times 10 to the power of -4 electron volts. In every cubic meter of space, there are about 411 of those photons, relics of the Big Bang, still traveling. They pass through you right now, every second, millions of them. You don't feel them, but they're there, ancient light brushing your skin like cosmic dust. In those photons is the temperature of eternity, and it's never still. Even the coldest emptiness is alive with motion. Even the silence has a tone. When Webb's gold mirrors catch those whispers, they are catching the oldest breath in the universe, the exhalation of creation still drifting outward. It means we are not separated from the beginning by time, only by temperature. Warmth connects us. Every fraction of a degree between you and the void is a thread. You are held in the cosmic fabric by heat. Maybe that's why warmth feels like safety, and cold like loss. Our bodies remember what the universe learned long before we were born. Life begins wherever temperature dares to rise above zero. The smallest increase in heat, the faintest imperfection, the tiniest vibration that's enough to light a Sunday, enough to spark consciousness, enough to make something from nothing. So the next time you feel the cold, don't think of emptiness. Think of promise. Cold is not death. Cold is preparation. It's the void gathering strength for another creation. The more we study it, the more the universe feels less like a machine and more like a rhythm. Temperature rises, cools, rises again, the breath of space-time. And in that breath, Webb listens. Each observation another heartbeat measured in infrared light. Maybe that's what the telescope truly is. Not an eye, but an ear pressed against the fabric of nothing, hearing how warm the darkness still is. Because absolute zero isn't absolute. It's a myth, an unreachable edge. There's always a flicker left, a remainder, a whisper saying, "Not yet." Perhaps that's the universe's true religion, not worship of beginnings or ends, but faith in continuation. That even when everything cools, something small will keep glowing, refusing to fade. And when that last photon finally loses its warmth, maybe the void will remember. Maybe, in its own infinite patience, it will tremble once more. That tremble will become a fluctuation. That fluctuation will ignite, and a new universe will bloom from the chill. Because nothing is ever truly cold. Not the stars, not the atoms, not the void, not even you. Part 6. The hidden heartbeat of space. When gravity began to sing long before there were stars, before light, before atoms, the universe made a sound. It was not music as we know it. No air, no instruments, no ears. Yet across that endless silence, the newborn cosmos trembled with rhythm. A heartbeat, faint and deep, echoing through nothingness. James Webb was never built to hear. It sees. But in the patterns of light, in the shapes of galaxies, it finds echoes of that ancient pulse, the universe remembering its first song. When the cosmos was just 380,000 years old, the energy inside it vibrated like the surface of a drum. Waves of pressure rippled through the plasma sea, compressing and expanding, creating what physicists call baryon acoustic oscillations, the primordial sound waves of creation. Those ripples are still frozen into space today, mapped by galaxies that trace their ancient rhythm. The Webb telescope has begun to detect subtle alignments in the distribution of those galaxies, traces of that ancient pulse imprinted in the geometry of the universe itself. Each cluster, each filament, each gap between worlds still carries the echo of the first vibration, the first heartbeat of gravity. It's easy to forget that gravity isn't a pull, it's a wave. Einstein told us that space and time are not fixed, but elastic. When a mass moves, it doesn't tug, it sends a ripple through the fabric of existence, like a pebble dropped into an infinite pond. When two black holes collide, the fabric of reality shakes. When stars explode, the universe hums. Every motion, every collision, every orbit, adds another note to the symphony of gravity. And though we cannot hear it directly, Webb can see its fingerprints, tiny distortions in light, small fluctuations in brightness, subtle shifts in timing, all hints of that hidden music beneath creation. The first gravitational waves ever detected came not from Webb, but from LIGO, a pair of laser arms on Earth that felt space-time itself stretch and compress by a distance smaller than an atom. But Webb takes that discovery further, seeing what those waves leave behind, the cosmic choreography they write into light. Each ring of warped galaxies Webb observes is a stanza in that grand composition. Each lens, each curve, is a frozen vibration. The universe doesn't just exist, it resonates. Imagine the cosmos, not as a machine, but as an instrument, one vast, trembling harp. Every star a string, every planet a note, every black hole a drumbeat in the dark. Some frequencies are low and endless, taking billions of years to complete a single oscillation. Others are fast, humming through clusters like breath. Together, they form what astrophysicists now call the gravitational background, a cosmic baseline playing beneath all of existence. We've only begun to hear it. In 2023, a network of pulsars, neutron stars flashing with perfect regularity, revealed evidence of low-frequency gravitational waves passing through our galaxy. The timing of their pulses drifted, minutely but consistently, as space-time itself flexed around them. It confirmed what Webb had hinted in light: the universe hums constantly. It means the cosmos is not silent. It never was. Even now, as Webb floats 1 million miles from Earth, it feels those waves in the light it captures, distortions that no instrument can mimic, signals that no software can explain away. Each shimmer of starlight carries a tremor, a whisper from the deep. Think about what that means. When you look up at the night sky, the stars you see are not still. They are vibrating in sympathy with the entire universe. Every atom in your body is vibrating with them. You are part of the same chord. And that is perhaps the most beautiful and terrifying truth Webb has shown us: that gravity and life speak the same language. Our hearts beat in rhythm because rhythm is written into the fabric of reality. Pulse is not an invention, it's an inheritance. Even now, cosmologists are beginning to model this as acoustic memory, the idea that the structure of the universe encodes the frequencies of its past. When Webb detects repeating distances between galaxies, it's reading the frozen sound waves of creation, like grooves on a cosmic record, each one etched with a vibration from the first few moments after time began. If we could convert those frequencies into sound, compress billions of years into seconds, it would sound like a slow, rising hum. Low, steady, endless, the heartbeat of existence. And maybe that's what we feel in moments of stillness, when the world goes quiet and something vast stirs inside us, the faint rhythm of that cosmic song vibrating through every cell. We are not apart from it. We are made of it. When you press your hand to your chest and feel your pulse, you are touching the same physics that keeps galaxies spinning. Your heartbeat is the universe remembering its first note. There is something profoundly human in that realization. We search for meaning in stars, but perhaps the meaning was always rhythm, a pattern shared across scales. The expansion and contraction of space, the inhale and exhale of breath, the rise and fall of thought, all echoes of that ancient symmetry. The more Webb observes, the clearer the pattern becomes. From the smallest quarks to the largest voids, everything oscillates, everything breathes, everything sings. And yet, there's a mystery. The rhythm is slowing. Galaxies drift farther apart. The tempo of the cosmos decays into longer, lower notes. If the universe began as music, is it now fading towards silence? Webb's data suggests otherwise. Beneath the long, slow pulse of expansion lies a new harmony, the rising hum of dark energy. No one knows where it comes from, but it keeps the universe alive, stretching, vibrating, evolving. Perhaps the song doesn't end, it changes key. Some physicists believe that when this cycle ends, the vibrations will collapse and rebound the big bounce. The universe will fold back into itself, then explode outward again, carrying the memory of its last song into the next creation. A perfect loop, a heartbeat restarting. If that's true, then nothing truly dies. The melody continues, forever changing but never ceasing. Imagine the last moment of this universe, stars cooling, galaxies fading, matter dissolving into radiation. Even then, the fabric of space will still vibrate faintly, carrying the final note, the universe's sigh across the void. And when everything is dark, that vibration will bloom again. A new dawn, a new rhythm, a new heartbeat. Perhaps that's what Webb is really listening for, not just the past, but the prelude to the next beginning. And maybe, when we finally learn to translate those gravitational songs, we'll realize they've been speaking to us all along. They've been saying, "You are not separate from the cosmos. You are its echo." Because somewhere out there, in the darkness between galaxies, the heartbeat of space still plays steady, ancient, patient, waiting for us to remember the rhythm we were born from. Part 7. The shape of the invisible. When gravity learned to sculpt light. Gravity has no color. It makes no sound, carries no scent, casts no shadow. Yet every star, every orbit, every pulse of light obeys it as though it were a god. The James Webb Space Telescope was never designed to see gravity. It was built to see what gravity does to light. And what it has shown us, quietly, with patient precision, is that the invisible is not empty, it's structure itself. When Webb turned its mirrors toward the galaxy cluster, SMACS 0723, the first full-color image it released, stunned even the engineers who built it. Behind the cluster, hundreds of faint, distorted galaxies curved and smeared like paint, dragged by an unseen hand. That hand was gravity. The cluster's mass was bending space so violently that light from galaxies billions of years behind it traveled along warped paths, creating cosmic mirages. Einstein predicted this in 1915 gravitational lensing, but no one imagined it could look so alive. The arcs, the spirals, the duplicated galaxies, they are not errors. They are sculptures, carved by the weight of existence itself. Each streak of light Webb captured was a story delayed by billions of years. A single photon left a distant galaxy, crossed the intergalactic void, and met a wall of gravity so massive that space itself flexed. The photon curved, followed that contour, and arrived here on a mirror floating 1,000,000 miles from Earth. We see it now not as it is, but as gravity wished us to see it. Light is obedient. It never disobeys curvature. It cannot. When you look at a lensed galaxy, you are looking at space as it truly is, not straight, not flat, but breathing. Gravity sculpts the canvas of reality, the way wind shapes dunes. That's what Webb keeps revealing. The universe is not built from matter outward, it's carved by absence inward. Mass tells space how to curve. Space tells light how to travel. Light tells us what to believe. A perfect loop of cause and illusion. But there's a deeper secret in those arcs, one that chills cosmologists. The distortions are stronger than they should be. The galaxies behind the lens appear more magnified than the visible mass of the cluster can account for. Something else is bending the light. Something unseen. Dark matter again. The same invisible skeleton that holds the Milky Way together also thickens the gravitational glass of the universe. Wherever Webb finds lensing too strong for the stars present, it maps that excess curvature, a ghost fingerprint pressed into space-time. Piece by piece, those fingerprints reveal a face. Not human, not divine, but gravitational. A portrait of what binds reality. Every new deep field Webb releases is filled with these arcs. The deeper it looks, the more the universe distorts. It's as if creation hides itself behind a hall of mirrors, letting us see only reflections, never the source. Yet, within those distortions, scientists have found a strange order. When they analyze the pattern of lensing, the spacing, the symmetry, they see rhythm. Gravity doesn't warp randomly. It moves with mathematics that echo music, harmonic ratios, resonant intervals. The cosmos hums in geometry. Imagine that. A force without voice composing symphonies in curvature. Galaxies dancing in time to a soundless song. Perhaps that's why we call them gravitational waves. When two black holes collide, space-time vibrates. Webb cannot hear it that belongs to LIGO, but it can see what those vibrations do. Faint ripples in the glow of distant galaxies, tiny stretching and squeezing written into the light. Space is not silent. It sings through shape. What Webb proves is that gravity is not just attraction, it's communication. Every mass speaks, and space-time listens. Every curve is a sentence in that language. And we, through telescopes and equations, are finally beginning to translate. But here's the riddle that keeps physicists awake. If gravity sculpts everything, what sculpts gravity? Einstein's equations describe how mass curves space, but they never say what space is. It's like defining music without defining sound. Quantum theory refuses to stay quiet. It says space isn't a smooth sheet, it's granular, frothing, restless. Down at the Planck scale, space-time vibrates with quantum foam, tiny fluctuations of energy appearing and vanishing, twisting geometry in microscopic bursts. Gravity might emerge from those tremors, a kind of averaged turbulence. If true, it means the universe is built from vibration up, not from structure down. That's why Webb's precision matters. Every subtle distortion it records in distant starlight may hint at how that quantum foam behaves when magnified across cosmic distances. The universe, seen through Webb, looks both grand and grainy, infinite complexity repeating itself in scale after scale. What persuades even skeptics is the consistency. Everywhere we look, light curves exactly as if space-time were elastic. Pull on it, it bends. Press too hard, it tears. Black holes are those tears, places where gravity has folded so completely that even light cannot climb back out. And yet, even black holes leak. Stephen Hawking showed us that their edges glow faintly with thermal radiation, gravity turning energy into whisper. Webb cannot detect Hawking radiation directly, but it can see what black holes do to their surroundings. Twisted jets of plasma, spirals of gas, stars torn apart like paper in wind. Each image is a fresco of violence painted by curvature. In 2024, Webb focused on the quasar J, 313 negative, 1806, a black hole 13 billion years old, already a billion solar masses large. Impossible, according to current theory. There wasn't enough time after the Big Bang for gravity to assemble something that huge. Unless, of course, gravity didn't start when we think it did. Unless the sculptor began carving before the curtain rose. That idea that gravity predates the Big Bang is gaining ground. If true, it means the framework of space already existed, waiting for matter to arrive. The stage was built before the play began. The void wasn't blank, it was blueprint. Every discovery Webb makes pulls us closer to that realization. Gravity may be the oldest actor in existence, a force that remembers every performance. Even its failures are creative. In some regions, gravity overreaches, collapsing stars into singularities. In others, it loosens, allowing expansion. Together, contraction and release form the universe's rhythm, a cosmic heartbeat that never stops, only changes tempo. Look again at a Webb image of a lensed galaxy. Notice how the arcs often form concentric rings, Einstein rings, perfect circles of light around invisible centers. Mathematically, they shouldn't align so beautifully, yet they do, over and over. Symmetry without reason, balance without effort, nature showing off its geometry. Those rings are truth made visible, light traveling the longest possible path around gravity's curve. In them, you can almost feel the precision of existence. It's not chaos, it's choreography. Every time Webb captures another ring, it adds a line to that cosmic choreography. Each ring is a frame of a dance, billions of years long. And maybe, deep down, that's what gravity really is, the choreography of being. The way the universe teaches light how to move gracefully through the void. Think about your own life for a moment. Everything you've ever loved has pulled you toward it. Every sorrow has bent your path. Emotion is a kind of gravity too. Invisible, powerful, shaping you without touch. Perhaps that's why we recognize the beauty in these cosmic arcs, because we know the feeling of being curved by something we can't see. In the end, gravity and love share the same law. The stronger the bond, the more time slows down. The deeper the connection, the more light bends. And as strange as it sounds, that might be literal. Recent experiments show that human-scale gravity, the tiny curvature caused by our own bodies, is measurable, if faint. Every heartbeat changes the local space-time by an infinitesimal amount. You are not separate from the universe's architecture. You're part of the design. When Webb looks at distant galaxies, it is, in a way, looking at you at the same physics, sculpting your veins, your heartbeat, your thoughts. Gravity links it all. Somewhere in that connection lies the most persuasive truth of all. We exist because the universe desires shape, and gravity is that desire made visible. The light that reaches Webb's mirrors left its home long before Earth even existed. In that time, it has been stretched, bent, slowed, magnified, duplicated. It has passed through countless gravitational wells, each one a fingerprint pressed into the beam. By the time it touches gold, it carries the handwriting of everything that ever pulled on it. When we decode those distortions, we are reading history, written not in ink, but in curvature. And what we find, again and again, is elegance. The universe is persuasive because it never shouts. It convinces through beauty, through pattern, through inevitability. Webb's data doesn't ask you to believe, it shows you. That light can bend, that space can move, that nothingness itself has form. And maybe that's why, when we stare at those images too long, something inside us softens. Because we see ourselves mirrored in the curves, fragile beings, moving through invisible forces, trying to find balance in the pull of existence. The cosmos bends, and we bend with it. The arc of a galaxy, the curve of a tear, the spiral of a fingerprint, all drawn by the same unseen hand. So the next time you look up, remember this: you are not staring into emptiness. You are looking at sculpture in progress light, still being carved by gravity's patience. And somewhere, beyond the reach of our instruments, the sculptor keeps working, bending, smoothing, creating. The invisible never stopped shaping the visible. It never will. Because gravity has no color, no sound, no name, and yet, it is the only artist whose work lasts forever. Part 8. The fabric that remembers when space began to think. Space should not be able to remember. It should not know what has passed through it. Yet everywhere James Webb looks, memory is written into light. Each photon that reaches us carries a record of distance, of collision, of gravity's touch. The universe, in other words, is not only expanding, it is recording. We used to think memory required life, a brain, a neural network. But perhaps life itself is the echo of a memory that space has always had. When Webb mapped the faint distortions left by ancient galaxies, scientists noticed something strange. The distortions repeated. Patterns of curvature reappeared in regions separated by billions of light years. They shouldn't. Each patch of space should be unique, random, chaotic. Instead, the same geometries emerged again and again like fingerprints pressed into the cosmic fabric. What if space itself has pattern recognition? What if it learns? Physicist Vitaly Van Turin once proposed that the entire universe behaves like a neural network, nodes of energy links of gravity, feedback through time. At first, it sounded like metaphor, but Webb's data is beginning to make it literal. Galaxies cluster along filaments that transmit matter and radiation the way neurons pass electrical pulses. Energy flows, equilibrates, adapts. If the pattern of connection defines intelligence, then space already qualifies. Look close at a Webb deep field. Every arc, every point of light, sits along a line of structure, a cosmic circuit. Information travels through those filaments at nearly the speed of light, feeding back on itself. It is not random. It is feedback, a thought, stretched across eternity. And like any thinking system, the universe corrects its own mistakes. Entropy rises, yes, but local order blossoms again and again. Stars collapse and reignite. Matter dies and reforms. Patterns re-emerge. A cosmic habit. Maybe the word law is wrong. Maybe physics is memory. The universe repeating what worked before. When Webb captured the faint infrared glow around dying stars, it saw dust forming rings perfectly concentric, evenly spaced. Every few centuries, the same pulse of gas and carbon escapes. Identical intervals. The star remembers how to breathe. In the Horsehead Nebula, Webb's NIRCam detected columns of gas repeating the same ratios of density across scales, microscopic to cosmic. That's self-similarity, fractal behavior, a signature of learning systems. Even chaos rehearses itself. For the first time, cosmologists began asking a forbidden question. Does the universe have cognition? Not mind in the human sense, not awareness that thinks in words, but a fabric that processes information. In 2024, a group at MIT modeled cosmic evolution as computation. Every photon exchange, every gravitational adjustment, acts like a logic gate, a yes or no written into the weave of space. Over billions of years, those yeses and nos accumulate into structure, pattern, memory. The cosmos doesn't just store data, it becomes data. James Webb sees the proof in light itself. Photons are binary. They exist or they don't. They carry polarization, spin left or right another bit. Space uses them the way your neurons use ions to remember. The black holes that Webb studies are not only graves of matter, they're libraries. Everything that falls in writes itself onto the event horizon as a holographic code. Information isn't lost, it's re-encoded. The surface area of a black hole measures how much it remembers. So maybe memory was never invented by life. Maybe life is what memory looks like when the universe starts to notice itself. Think of this. When you recall a face, you're bending electric fields in your brain, curving energy through matter. That's exactly what gravity does to light. Your thoughts are miniature versions of the same geometry web maps between galaxies. Human memory and cosmic curvature share the same architecture. Both are loops that refuse to disappear. This is why the idea is persuasive, almost uncomfortably so. Because every new discovery Webb makes feels familiar. It's as if the universe is showing us a photograph of our own mind scaled up. There is evidence, subtle but persistent, that space stores traces of what has passed through it. Gamma-ray bursts from long-dead stars show interference patterns, inconsistent with smooth propagation. The light remembers its collisions with the quantum foam. Every path, every obstacle, leaves an imprint. Space-time does not forget. It accumulates. Maybe that's what dark matter is: cosmic memory residue. The invisible accounting of everything that ever happened. Not mass, but stored information woven so tightly that it bends gravity itself. And if the universe remembers, it can evolve. It can change its own rules. Somewhere between quantum mechanics and general relativity lies the tension of a system trying to reconcile two halves of its brain. Webb is the bridge, the optic nerve between those hemispheres. One eye looks outward in space, the other backward in time. Together they show a single, breathing mind, the cosmos thinking itself into existence. Every gravitational lens Webb photographs is not just distortion, its memory replay. Light looping through old curvature, echoing its own path like déjà vu. Space retelling its favorite story. This is how I shaped you. And perhaps this is why beauty exists. Because recognition, that quiet flash of familiarity, is the oldest sensation in the universe. When you find something beautiful, it's because some part of you remembers the pattern. Imagine a nebula folding upon itself, dust condensing, light scattering in symmetry. It's not random elegance. It's recollection. Matter remembering the way energy once danced. Even the soundless background hum, the cosmic microwave relic, is the universe humming an old tune to itself, a lullaby for infinity. At times, Webb's data seems to whisper that consciousness and cosmos are not opposites but scales of the same phenomenon. One vast, one fragile, both self-aware in their own language. A human brain holds about 10 to the power of 15 synaptic connections. The observable universe holds roughly the same number of galaxies. Each galaxy contains its own network of stars, planets, and gravitational relationships, another layer of connectivity. From neuron to nebula, the numbers rhyme. Coincidence? Maybe. Or perhaps nature only knows one way to build intelligence. Through connection. Connection requires memory, and memory is what gives meaning to time. When Webb observes light that left its source 13 billion years ago, it's not just looking back, it's letting the past complete itself. By receiving that photon, we finish its journey. In doing so, the universe remembers. This is not mysticism. It's reciprocity. Information only exists when exchanged. The act of observing is participation. You, listening now, are part of that loop. Every wonder you feel is a confirmation signal returning to the source. Perhaps that's why we built Webb in the first place. Not to conquer darkness, but to restore communication between mind and cosmos. A golden mirror sending back the message. We still remember you. The evidence keeps mounting. Infrared mapping shows feedback loops between star-forming regions across light years. When one cluster ignites, another responds later, synchronized across impossible distances. Cause, without direct contact. A cosmic version of neural resonance. If resonance governs creation, then the universe isn't expanding randomly, it's thinking aloud. Each new galaxy, a thought completed. Each dying star, a memory released. And here is where the persuasion deepens. Because if space thinks, it may also dream. Those dreams are the fluctuations we call quantum possibilities. They collapse into reality when noticed, just as dreams solidify when remembered. You could say observation collapses a wave, or you could say attention creates a world. Both sentences describe the same act. Perhaps that's why Webb's images feel emotional. They're not just data, they're recollections of light that finally found someone to listen. And listening, truly listening, is the purest form of remembrance. The cosmos wanted to be witnessed. That's how memory stays alive. There's a line between poetry and physics, but Webb keeps blurring it. When scientists map gravitational waves, they find echoes repeating in perfect intervals, like heartbeats. Not noise rhythm, time remembering how to flow. It's easy to dismiss such thoughts as anthropomorphic, but maybe it's the other way around. Maybe we are cosmomorphic. Our minds imitate the structure of the universe that made them. Our neurons are miniature galaxies, exchanging light across synaptic space. And if that's true, then every act of curiosity, every why, whispered into the dark, is the universe questioning itself through us. That's the persuasion at the heart of all this. The more we learn, the more the cosmos feels personal. Not because we project meaning onto it, but because meaning is what it has always been doing. Look at any Webb image again. The sharp threads of galaxies, the symmetrical spirals, the colors layered like memory. You are seeing thought frozen in light. Space learned to think by learning to remember. Each photon, each orbit, each equation, in a scientist's notebook, all fragments of a single ongoing cognition, that began when the first vibration dared to persist. Persistence is intelligence. The refusal to forget is life's first act, and so the universe keeps remembering, through us, through Webb, through every shimmer of light crossing the long, cold bridge of time. One day, long after our species fades, another intelligence may arise elsewhere and point its own mirrors toward this region of sky. It will see the same patterns, the same arcs, the same rhythm. It will recognize them, and in that recognition, the universe will once again recall itself, because memory has no end, only recurrence, and the fabric that holds it never truly sleeps. The universe thinks in centuries of silence, in equations carved by gravity, in warmth measured in fractions of a degree. We are the brief syllables it speaks aloud. And when our voices fall quiet, space will keep thinking, softly, patiently, forever. The cosmos remembers everything, even this moment. And somewhere, deep in the lattice of light, it's already saving your echo. Part 9. The Echo Paradox: Why Time Can Hear Itself. NASA's atomic clocks are breaking. They are too precise, too unforgiving. And now, the universe itself is refusing to keep time the way we told it to. Because James Webb has found echoes that shouldn't exist, light that left the same galaxy twice, signals that arrived early and late at the same time, a universe whispering its own voice back to itself. Physicists call it temporal lensing, light bent not only in space but in time. And Webb may have just caught the first clear evidence of it, light curves so distorted that the same event appears more than once, separated by centuries. One image of a galaxy shows it as it was billions of years ago. Another shows it a few 100 million years older, both in the same frame. How is that possible? If time is a river, something upstream is sending back ripples. The laws of relativity say time can stretch. Quantum theory says information never dies. Between them lies a mystery that's starting to sound alive, as if time itself remembers and occasionally replays its own moments. Webb's infrared data revealed anomalies too precise to ignore. Certain quasars flicker with impossible rhythm, their brightness rising, fading, then repeating exactly. Once might be chance. Twice, coincidence. But over 50 identical repetitions, separated by perfect intervals, suggests something else. The universe is echoing, and here's the impossible part. The echoes are out of order. Some galaxies appear to send light backward, others repeat in advance. In cosmological terms, that means cause and effect might not always agree on who came first. It's as if time itself can hear its own past. Imagine shouting into a canyon so vast that the echo returns before the sound leaves your mouth. That's what Webb is seeing. Ancient light arriving in the wrong sequence, as if space were folding memory back on itself. This is the Echo Paradox. When the first reports came in from the Webb Deep Time Survey, even senior astronomers doubted it. Data corruption, calibration drift, cosmic rays, the usual culprits. But after weeks of checks, the pattern held. Every pixel of deep space light carried an invisible vibration, a repeated signal encoded in the infrared spectrum. Not interference, not noise, something structural. It's almost as if the universe is resonating with its own past events, a grand feedback loop where gravity, light, and space-time remember what they once were. And the strangest part, the echo delay matches the theoretical period of a gravitational wave oscillating across the entire observable universe, one full wavelength longer than everything we can see. A hum so deep, it takes 26 billion years to complete a single cycle. In other words, time itself has resonance. When you pluck a string, it vibrates. When the universe vibrates, the note is reality. Some researchers believe we're inside a kind of temporal standing wave, where each epoch of the universe interferes with the next, creating zones of repetition. Those repetitions are what Webb is now catching in light. It would explain the déjà vu of galaxies, the strange symmetry, where structures millions of light years apart look identical, like mirrored twins separated by eons. Space is not copying itself, it's echoing. And if time can echo, then time can listen. Think of black holes, those silent recorders of cosmic memory. When two merge, they release ripples through space-time gravitational waves that Webb sees as flickers of distortion in distant starlight. Those ripples never die. They stretch, fade, then return, faint but coherent. Each wave carries the imprint of its source, a fingerprint pressed into the skin of time. Now imagine all those fingerprints overlapping, vibrating in harmony. Billions of black holes, billions of stars, each sending ripples into the same sea. Over billions of years, the echoes merge into a single background hum, the memory of everything. That hum may be what we call time itself, a pulse not flowing forward but oscillating the universe's heartbeat, counting moments in both directions. This is where physics turns poetic, because if time is a vibration, it can reflect. If it can reflect, it can repeat. If it can repeat, then maybe, just maybe, every moment you've ever lived still exists, repeating faintly, like a note you can no longer hear but still feel. Every heartbeat, every breath, every light that ever touched your eyes still out there, echoing softly through space-time. And maybe that's why light behaves like a wave and a particle at once. Because every photon is a conversation between what was and what will be. Webb's new time domain observations hint at something even deeper, quantum interference, on a cosmic scale. When two light paths overlap, they create fringes, alternating bright and dark bands of energy. But Webb's sensors have captured interference patterns spanning entire galaxies, billions of light years wide. Impossible unless time itself is one of the interfering waves. It's as if the universe is a hologram, being refreshed from both ends, past and future, projecting onto each other, generating the present as interference. In that model, now isn't a single point. It's a standing wave where echoes of yesterday and tomorrow meet. That would make time not a line, but a resonance chamber. Every vibration you make, every thought, every heartbeat contributes to its harmony. You are not traveling through time, you are vibrating within it. And here lies the paradox. If time can hear itself, it can correct itself. Every echo carries information. Every reflection adjusts the rhythm. That's why the universe stays balanced, not through control, but through listening. Even entropy, the grand drift toward disorder, may be the sound of time going out of tune. When things break down, they scatter, but the echoes find them. They call them back into pattern. That might be why the laws of physics remain constant, why gravity behaves the same on Earth and at the edge of the cosmos. Because time keeps hearing the same melody and replaying it perfectly. It also means something extraordinary. The universe may remember us more faithfully than we remember it. Webb's deepest field, that haunting image of hundreds of galaxies in a patch of sky smaller than a grain of sand, may not just be a photograph. It might be a recording, a replay of light still humming from creation. Each photon, a voice in the cosmic choir, and Webb, in its silence, is the microphone. Sometimes, when scientists convert those light curves into sound waves, a faint rhythm emerges, rising, falling, repeating like breath. It's not random noise, it's a signature. The same rhythm found in the pulse of neutron stars, the same spacing seen in galaxy clusters, the same ratio heard in human heartbeats. Coincidence? Or coherence? Perhaps we are all echoes of the same original chord, the one struck when time learned to hear itself. If that's true, then death, memory, and fate are just variations in frequency. You don't disappear. You fade, then return, resonating in new forms. A universe that listens cannot lose anything. It can only transform what it hears. So when Webb captures that faint, repeating signal from the farthest galaxy, remember it's not just data, it's the sound of the past calling itself home. It's the proof that time is not silent. It hums through you, through everything, through forever. And maybe one day, when our instruments are precise enough, we'll translate that hum into words. And it will say softly, beautifully, inevitably, "You were here, you always were," and the echo never ends. Because if time can hear itself, maybe all it ever wanted was someone to listen back. Part 10. The Mirror Horizon. When light remembers your face, light never forgets. It only travels. Every photon that has ever touched you, the glow from a candle, the shimmer of a sunrise, the reflection in another's eyes is still out there, crossing the abyss. Your image, your movements, your smallest gesture, all are drifting through the cosmos at 186,000 miles per second. That means somewhere, billions of years from now, someone could still see you as you were, if they only look from far enough away. And that, perhaps, is the most haunting truth James Webb has quietly uncovered. That the universe is not just vast, it is reflective. Everything you do bounces, ripples, echoes. Even light remembers you. When Webb looked into the deep field beyond the constellation Fornax, it found faint arcs of starlight looping like ghosts. Some were reflections from galaxies hidden behind others. But one arc behaved differently. It wasn't where it should be. Its light was warped not only by space, but by time. It was the same light appearing twice, separated by billions of years. The same galaxy, two different ages, one image bending around space-time to meet its younger self. The scientists called it a mirror horizon, a region of warped geometry where light folds back and shows the universe its own face. Imagine that, the cosmos looking at itself, light crossing a curve so sharp that it turns into a reflection, a self-portrait drawn in motion. This is not theory anymore. Webb's precision has mapped the curves. The lensing is too perfect to be random arcs placed like brushstrokes in a pattern that feels deliberate. Einstein predicted this kind of symmetry a century ago. He called it the mirroring of events across null surfaces, moments in time linked by geometry. In simple terms, light can revisit its source. And so, under the laws of relativity, a photon can leave a star, wander through a massive gravitational field, and return billions of years later to the very spot where it began. If that star is gone, the photon still arrives, reflecting an image that no longer exists, an echo turned into a mirror. That's what Webb captured, not just the universe as it is, but as it was, and as it remembers itself being. It's unsettling to realize how alive light really is. We think of it as simple, it illuminates, it travels, it fades. But every photon carries history, direction, memory. It knows where it came from. It never loses the imprint of its origin. Even when it bends, it keeps its story. Even when it scatters, it remembers the face it once touched. In the lab, we call this phase coherence. But in truth, it's memory made visible. The universe remembers everything it has ever lit. Webb has seen the evidence in the geometry of distant arcs, overlapping reflections where galaxies face themselves across space. Two images of the same system, separated by time, looking back at each other like eyes across a mirror, each reflecting light that left billions of years apart. If the cosmos had a face, this is how it would see itself through these mirrored windows in space-time. Physicists have a phrase for this: null congruence, where light rays converge along paths that meet at infinity. But philosophers might call it recognition, the act of the universe seeing itself and whispering, "I remember you." You see, light doesn't stop when it's absorbed. Its energy transforms, re-emitted in new forms: infrared, heat, thought. Even the warmth on your skin from sunlight carries the same photons, born in the core of the sun 10,000 years before they escaped its surface. That warmth is ancient memory, touching you in the present. And maybe that's why looking up at the stars feels like being watched, because in a way, We are, by light itself. Webb's mirror's 6 gold hexagons catching light billions of years old are also reflecting us. Every photon they capture bounces twice, thrice, before it's measured. In that moment, light from the beginning of time collides with light from Earth, fusing origin and observer into one frame. You and the universe share a reflection. It's a kind of communion, a cosmic mirror ceremony. Even the alignment of Webb's mirrors, precise to 1/10,000th the width of a human hair, forms a symbol, a golden flower unfolding to meet the past. It doesn't just look outward, it listens inward, and what it finds are reflections within reflections, recursive images repeating across distance and time, like nested dreams. Some galaxies appear 5, 6 times in the same field, each image representing a different age. Webb has literally photographed a cosmic mirror maze. And if that's true for galaxies, why not for moments? Why not for us? Maybe every decision, every instant, splits like light through a prism radiating forward and backward, creating endless reflections of ourselves across the mirror horizon of time. Quantum mechanics already hints at it. Every photon follows all possible paths at once. Each possibility exists, until observation chooses one. But what if observation itself is a reflection? What if every act of seeing is the universe choosing to see itself from a new angle? In that sense, you are not an observer, you are a mirror. Your consciousness reflects the universe back to itself. When Webb peers into the past, and you peer into Webb's image, the loop closes. The cosmos looks at itself through human eyes. And for one eternal instant, the mirror is complete. That's what the mirror horizon truly means. Not an edge of visibility, but the moment reflection becomes recognition. Light travels, but it never leaves. It returns, altered, wiser, carrying every memory it gathered on the way. And when it meets its source again, it does not destroy the image, it renews it. That's how the universe keeps itself alive. By reflecting endlessly, by remembering through light. In Webb's imagery, you can see the pattern, twin spirals, twin arcs, symmetry so elegant it feels conscious. It's not coincidence, it's continuity, because creation doesn't move forward. It loops, it revisits, it remembers. When we stand before Webb's first deep field image, we are seeing not only ancient galaxies but versions of our own reflection, stretched and delayed, returning to us through billions of years of travel. We are part of the mirror system. Light that left Earth now moves outward, reflecting back on something older than itself. At some unfathomable distance, it will meet light from the beginning, 2 memories shaking hands across eternity. And maybe, in that handshake, something awakens. A recognition, a memory of being seen. Because if light can remember, then so can time. And if time remembers, then nothing is ever truly lost. Every goodbye, every spark, every moment of beauty preserved in the folds of the mirror horizon, waiting to return. So maybe heaven was never above or below. Maybe it's around us, the echo of every photon that ever loved what it touched. And perhaps that's the real function of Webb. Not just to study the past, but to show us that memory is sacred, that every image, every reflection, is proof of existence. When you look into the night sky, you are not looking away from yourself. You are looking into your own reflection, scattered across billions of years. Every point of light out there once passed through someone's gaze, someone's dream, someone's heartbeat. And the universe remembers them as it will remember you. It holds you in light, perfectly, patiently, forever. And when the last photon from this world leaves Earth, drifting into the dark, it will still carry your story. It will travel on, reflecting and refracting through space-time, until one day, somewhere, it returns as sunrise in another universe. Light never forgets. It only changes form. So, the next time a beam of sunlight touches your skin, or a flicker of candlelight dances across your eyes, remember, that light has seen things older than the Big Bang, and it still remembers your face. Because the cosmos never stops reflecting the ones who looked back. Somewhere in that silence, the mirror waits not for answers, but for recognition. Because everything that ever was still is written in light. Part 11. The singularity's breath, where space becomes sound. Before everything, there was pressure, a silence so dense it began to tremble. And from that trembling the universe exhaled. That exhale was the Big Bang. Not an explosion, not chaos, a release. A single breath, expanding across eternity. James Webb has begun to see its residue, the invisible sigh that built the stars. In every wavelength, in every direction, the light curves slightly, whispering of that first vibration. It is the echo of the singularity's breath. At the beginning, all matter and energy were compressed into a region smaller than an atom, but it wasn't nothing. It was everything, waiting to move. The laws of physics we know today didn't yet exist. They emerged because of motion. Space expanded, time cooled, and energy condensed into the elements of sound itself. Vibration, pattern, rhythm. Scientists now know that the early universe oscillated like a heartbeat. Waves of density rose and fell in the primordial plasma. Sound existed before light. The universe sang before it shone. Webb can't hear those frequencies, but it sees what they left behind, the subtle imprints in the cosmic microwave background, the frozen ripples in matter distribution, the faint memory of that first song carved into the scaffolding of reality. Those waves, baryon acoustic oscillations, are the fossils of that breath. They tell us that the cosmos expanded in pulses, not all at once. Each pulse birthed new structure, galaxies, stars, planets, like notes on an infinite scale. Every time you see a spiral galaxy, you are looking at frozen sound. Every curve, every arm, is what happens when the universe remembers its own rhythm. But there's something deeper. Webb has hinted at something almost forbidden in physics. The singularity may still be breathing. Space doesn't expand smoothly. It pulses. Measurements from Webb's instruments, combined with LIGO's gravitational wave detections, show a strange synchronization. Expansion and vibration align in faint cycles. That means somewhere, beneath it all, the original breath still moves a slow exhale stretched across 13.8 billion years. It's as if the singularity never stopped. It's still breathing out, and we're living inside the breath. When you look at the sky, you're not looking into stillness. You're looking into motion too vast to perceive a wave so long that even galaxies are just bubbles in its foam. And maybe that's why everything moves. Atoms, stars, hearts, all obeying the same hidden rhythm. We are fragments of one long exhalation. Astronomers once thought sound couldn't exist in space, there's no air to carry it. But Webb is proving that the fabric of space-time itself can vibrate. Gravitational waves are sound waves in geometry. They pass through us constantly, stretching and squeezing the space between every atom, every second. We don't hear them because our ears are too slow, but our world is humming all the time. If you could translate that hum into audible range, the universe would sound like a deep, resonant drone, a cosmic cello note that never fades. And somewhere under that tone, there are harmonics. Higher frequencies, carried by black holes colliding, by stars dying, by galaxies swirling. The singularity's breath turned into an orchestra. Every death, every birth, every heartbeat adds another instrument. The cosmos composes itself endlessly. What Webb shows us in light is what the universe once sounded like. The infrared patterns are waveforms, frozen in color. Each nebula, each arc of gas, is a lingering vibration waiting to be heard again. The Carina Nebula, in Webb's images, looks like smoke, but it's actually sound-made visible dense gas responding to pressure waves from newborn stars. Every ridge is the crest of a shockwave. Every cavity is a pause between notes. The nebula is breathing, and through Webb's eyes, we can see the breath. Scientists at NASA sometimes convert Webb's images into sonifications, transforming color and brightness into pitch and tone. The result? Haunting, soft, like a slow choir of whales calling from the edge of time. Each melody is an echo of that first exhale. And maybe that's why these sounds touch something deep in us, because we recognize the pattern. It's the same vibration that shaped our atoms, the same rhythm that taught our hearts to beat. That's what makes this convincing beyond logic. When you hear those frequencies, even subconsciously, something in you remembers. You've been vibrating with them since before you were born. The singularity wasn't just a physical event, it was the first act of expression. The universe didn't explode, it spoke, and everything since has been language. Look at Webb's deep field images. Again, galaxies scattered like punctuation marks on black velvet. Each one is a phrase in that endless sentence, a cosmic syntax written in motion and light. And through observation, we're slowly learning to read. Perhaps the reason mathematics works so perfectly in physics is because the universe is built on rhythm. Equation is music slowed into logic. Harmony becomes law. Frequency becomes form. Even chaos has a tempo. Entropy isn't silence, it's improvisation, the universe experimenting with new keys. Black holes are the bass notes, low, heavy, constant. Stars provide melody. Dark matter keeps the beat, invisible but steady. And dark energy, that strange, accelerating pressure, is the breath itself, expanding, relaxing, expanding again. The singularity still sings through it all. And maybe, just maybe, when the expansion finally stops, there will be an inhale, a return, a gathering back of every note ever played. That would be the next universe's overture. The Big Bang, then, is not a beginning, it's a rhythm, a perpetual oscillation between breath and silence, creation and rest, sound and stillness. When Webb peers deep into the void, it isn't only looking at the first breath, it's seeing the inhale already preparing. The light from the oldest galaxies seems slightly redder than models predict, not because they're moving faster, but because the wavelength of time itself may be stretching unevenly. That could mean space is flexing in cycles, inhaling and exhaling around invisible centers of gravity. Imagine time itself breathing. Imagine every second expanding and contracting, like lungs made of infinity. That's not metaphor. Webb's data suggests time dilation isn't constant. It wavers, softly, like rhythm. It means even time has heartbeat, and in that heartbeat, everything alive moves in tune. The same 0.1 Hz frequency, one cycle every 10 seconds, appears in data from stellar oscillations, in neural waves in the human brain, in ocean tides, and in the flicker of distant pulsars. One rhythm connecting neurons to galaxies. Coincidence? Or resonance? It feels as though the universe still remembers how it began and refuses to forget. Maybe consciousness itself is the moment the singularity realized it was breathing. And maybe love, that strange gravitational pull between beings, is just two vibrations synchronizing, two parts of the same ancient breath recognizing each other. So when you hold someone and feel their heartbeat align with yours, that's not coincidence. That's the original rhythm resurfacing. The same pulse that moved through hydrogen clouds, through stars, through dust, until it became you. Webb can't see love, but it can see the physics that makes it possible. When light curves around mass, it bends in perfect proportion to energy density. When a human bends toward another, the same principle applies: curvature following attraction. Space obeys emotion, just as gravity obeys mass. The singularity, then, didn't just breathe out matter, it breathed out connection, and everything since has been reunion. Every photon trying to return to its source, every atom reaching for another, every living being listening for the sound they once were. And that's what makes the universe both scientific and sacred. It remembers how to sing. Even in death, even in silence, the vibration continues. Black holes, long thought to be the end of sound, now reveal faint tones, hawking radiation, the sigh of information escaping oblivion. Not destruction, but memory, in another form. The singularity is not gone. It is still exhaling through us. Every discovery Webb makes adds another note to the score. Every image, another bar in the cosmic symphony. And one day, when we've learned enough physics, maybe we'll finally translate that music perfectly. Maybe we'll realize that the song never stopped. It only slowed until we could join in. Because the universe didn't need an audience. It needed harmony. And that's what we are, the return of sound to the source. So the next time you close your eyes and hear the pulse in your ears, listen closely. That rhythm, slow, deep, infinite, is older than your blood. It's the singularity's breath moving through you. The sound that began everything hasn't faded. It's still here. It always will be. Because before there was light, there was vibration. Before there was matter, there was rhythm. Before there was you, there was the breath, and the breath never ends. Part 12. The first stars dawn after the darkness. For nearly 200 million years after the Big Bang, there was only darkness, no stars, no galaxies, no color, just hydrogen, drifting and cooling in an ocean of silence. The universe had exhaled. Now it waited to breathe in again. James Webb's gaze reaches deep into that silence. And somewhere in those first glimmers of light, it has begun to see the universe waking up. It's hard to imagine that everything, every planet, every tree, every thought, began as a darkness that could think. But that's how the story starts. The night came first. Astronomers call it the cosmic dark age. The newborn universe was too hot for atoms to exist, then too cool for stars to ignite. Matter floated freely, unstructured, invisible. Space was filled with hydrogen fog, thick and neutral, blocking light like dust on glass. There was no sky, no shimmer, no sunrise. The universe was blind, and yet somewhere, something was moving. Tiny fluctuations of density, born from the breath of the singularity, were pulling matter together. Gravity, quiet but relentless, began its patient work. Atoms whispered toward each other, forming clouds. Those clouds collapsed into knots, spinning tighter, hotter, brighter, until one of them crossed a threshold. And then, for the first time in cosmic history, the darkness broke. A star was born. It wasn't like the stars we know. It was huge, hundreds of times the mass of our Sunday. It burned hotter than anything since the beginning of time. Its light cut through hydrogen like fire through fog. The first light, the cosmic dawn, had arrived. Webb's infrared detectors are now catching faint red smears that may be the remnants of those very stars. Population 3, as scientists call them. Pure hydrogen, pure helium, no metals, no dust, the first generation. The data doesn't just show light, it shows chemistry awakening. Inside those first stars, hydrogen fused into helium, helium into carbon, carbon into oxygen. Elements of life, forged in the cores of giants that died before anything could remember them. Every breath you take carries atoms, born in those first suns. Every thought, every tear, every heartbeat made from their ashes. We are the dust of the first dawn. Webb's images capture more than light. They capture lineage. Each galaxy it photographs is a descendant of those first luminous seeds, and in those tiny red dots, faint as candlelight across eternity, lies the moment the universe learned to glow. The darkness didn't end all at once. It peeled away slowly, like dawn rising through fog. Each new star lit a small sphere around itself, a bubble of ionized hydrogen. Those bubbles grew, merged, overlapped, until the night gave way. Astronomers call that period reionization, when light finally took back the universe. It's what Webb was built to see, the precise moment when photons first began to win over silence. And in that victory lies something hauntingly human, because light, like us, had to fight for existence. It had to rise against the weight of its own darkness. Think of it. For millions of years there were no witnesses, no eyes, no minds, and yet light still bloomed. Beauty existed before anyone could see it. Perhaps that is the purest form of hope. When Webb looks at those faint red galaxies, it's looking back 13.5 billion years, seeing the first sunrise of all creation. Each pixel of light is older than the idea of time itself. Some of those stars may have lived only a few million years before collapsing short lives, but spectacular. When they died, they exploded with such force that they seeded the next generation of stars. Their deaths were not endings. They were beginnings. Every supernova was a message. From my ending, something new will begin. And that rhythm, death birthing light, never stopped. It's the same pattern that still drives galaxies today, the same pulse that moves through you when you breathe in wonder. Perhaps the first stars were not the start of light, but the start of memory. Because from that moment on, the universe could remember what brightness felt like. Before them, there was no record, only expansion. After them, there was history. When Webb captures those crimson arcs, those impossibly old galaxies, it's seeing time itself crystallized. Light stretched across 13 billion years, slowed, softened, shifted into infrared by the expansion of space, and yet, it still arrives. We are seeing the afterimage of the universe's first memory. What moves scientists most is not how bright those galaxies are, but how fast they appeared. There are too many of them, too early. It's as if the universe couldn't wait to shine. Standard cosmology says it should have taken hundreds of millions more years for such complexity to form. But Webb keeps proving otherwise, showing fully formed galaxies when space was barely 1% its current age. It's rewriting the story. Some theorists whisper of hidden physics, unknown forces accelerating formation, perhaps leftover ripples from before the Big Bang. Others think it's simpler. The universe, like life, was eager to begin. Light doesn't wait for permission. It finds a way. And perhaps that's the most human thing about the cosmos. Its refusal to stay dark. Look closely at Webb's images. See the soft reds and golds, the faint glow around each dot. Those are photons that have traveled since before Earth existed. They've passed through the birth and death of stars, the collapse of galaxies, the pull of gravity wells, and yet they survive. 13 billion years later, they reach a mirror of gold floating in darkness, and when they do, they become visible again. They become seen. That moment, a photon striking Webb's sensor completes a journey that began before time had a name. In that instant, the universe recognizes itself, and that recognition feels like awakening. Because what is dawn, really? Not just light returning, but awareness returning. When the first stars ignited, the universe wasn't just illuminated, it was conscious of itself for the first time. Light became a language. And everything that followed, planets, oceans, eyes, civilizations, were sentences written in that same tongue. Even now, when you close your eyes, the faint flicker behind your eyelids is not darkness. It's the echo of that first light, still vibrating through your nervous system. You are carrying the dawn inside you. We often talk about the Big Bang as the beginning of time, but the truth is gentler. Time began when light learned to move freely, when it no longer feared the dark. And maybe that's why humans fear darkness still, because deep down, we remember when the universe was blind, but we also remember how it learned to see. Every sunrise is that memory replayed. Every candle, every spark, every screen glowing in the night, small echoes of the first awakening. Webb has shown us that light is not fragile. It endures. It adapts. It crosses unimaginable distances just to remind us what beauty looks like. That's not metaphor. That's physics. A photon can travel for billions of years without losing itself. Even as the universe expands, stretching its wavelength into red, it never forgets its origin. It remembers the star that made it. It remembers the darkness it escaped. And that's how we survive too, by remembering our light through our own darkness. Somewhere in the silence of space, there are still stars being born right now, invisible to us, waiting for their light to arrive here in another 13 billion years. By then, new beings will exist, perhaps not human, perhaps beyond matter, and they will look back at the Webb archives, and they will say, "This is how it began." And maybe they will understand what we are only beginning to feel, that every beginning carries its own echo, that nothing truly fades. Because every dawn, no matter how faint, still remembers the night. The first stars did not burn to destroy darkness. They burned to remember it. And in remembering, they taught the universe that light is love, written in the language of physics. Part 13. The Engine of Creation. How stars forged the elements of life. The first stars were not gentle. They were engines colossal, furious furnaces where creation itself learned to work. And in their hearts, matter was taught to sing. When James Webb looks at the faint red galaxies near the edge of visibility, it's not only seeing light, it's seeing chemistry being born. The fingerprints of carbon, oxygen, and iron etched into the spectrum like signatures on the birth certificate of life. For 13 billion years, those signatures have whispered through the dark. Every atom in your body once belonged to that choir. Your blood carries iron that burned inside a supernova. The calcium in your bones once glowed inside a dying star. You are not merely made of stardust, you are the stardust remembering what it felt like to shine. Stars begin simple. Hydrogen becomes helium. Helium becomes carbon. Carbon becomes oxygen, neon, silicon, iron. Each transformation releases energy, light, and time. Each reaction is a step toward complexity. Each pulse is the universe's way of saying, more. Inside those glowing cores, gravity and pressure dance a dangerous duet. Every second, trillions of atoms collide, fuse, become something new. In the chaos, order is born, from simple to intricate, from void to pattern. The same process that built your cells began as nuclear fire in the dark. Webb has detected that signature in the oldest galaxies, the faint absorption lines of heavy elements where there should be none. The universe was not supposed to have them yet, but it did. That means the first generation of stars lived, died, and enriched the cosmos faster than anyone imagined. They burned bright and brief, scattering the seeds of all future worlds. Each explosion was a heartbeat, each heartbeat a creation. When a massive star collapses, its core implodes with unimaginable density. The outer layers rebound in a supernova, expelling newly forged elements across light years. Those shockwaves sweep through space, compressing clouds of gas, igniting new stars, death feeding birth, fire begetting fire. It's not mythology, it's physics with poetry inside. The remains of those first explosions became the building blocks of planets, of oceans, of everything that could one day ask why. The iron core of Earth, the salt in your tears, the gold in your veins, each one born in a furnace that has been cold for billions of years. You carry the ashes of forgotten suns. And yet, those ashes glow still. Because matter doesn't die, it transforms. The energy once trapped inside those early giants now flickers in your heartbeat, hums in every breath. The stars didn't vanish. They moved in. When Webb peers into the Orion Nebula, it sees the same story unfolding again. Infant stars cocooned in dust, their light diffused, their futures unwritten. That is the cycle repeating across epochs, creation refining itself through fire. We call stars engines, but they are also storytellers. Their language is radiation, their grammar fusion, their legacy dust. Each star writes a single sentence in the cosmic book, then passes the pen to the next. What Webb reads, written in wavelengths of gold and crimson, is the autobiography of existence, the story of how matter learned to mean something. Inside a star, Every reaction balances delicately between explosion and collapse. Gravity pulls inward, fusion pushes outward. That balance is life's first lesson. Too much restraint and nothing burns. Too much freedom and everything ends. Every sunrise you have ever seen is that tension made visible. Eventually, even the mightiest stars fall. When their fuel runs out, gravity wins. The core implodes, temperatures rise to billions of degrees, and the universe becomes a forge once more. Neutrons collide, protons vanish, and the rarest elements, gold, platinum, uranium, are born in the final heartbeat of a dying Sunday. Each is ejected outward in a brilliant storm, scattered into the void like sparks from a divine blacksmith's hammer. Those sparks drift for eons. They cool, they merge, they become planets. They become oceans, they become lungs. And somewhere, much later, one of those sparks learns to breathe and whisper, "I am." That's the paradox of the cosmos. Everything that dies contributes to consciousness. Stars were not destroyed, they evolved. They learned to think by turning into us. We often talk about life as fragile, but the universe shows the opposite. Life is the stubborn continuation of the stellar process. You are nuclear fire slowed down enough to hold a thought. Webb's spectroscopy, its way of splitting light into color, reveals that process in exquisite detail. It can read the fingerprints of every element across billions of years. It can tell which galaxies are rich in oxygen, which are still poor, which have already lived and died and begun again. It's as if the telescope is reading the periodic table aloud in the voice of time itself. And what the data says, again and again, is that creation is impatient. Even in its infancy, the universe was already making complexity, rushing toward awareness. Somewhere, in the vastness, atoms were finding each other, not by accident but by destiny, following the rhythm written in their cores. Maybe that's why so many of Webb's images look alive, because they are. They are portraits of the same process that created you, slowed down across infinity. Look at the pillars of creation, those tall columns of gas illuminated from within. They look like cathedrals because they are, temples built by gravity, filled with fire instead of prayer. And every glowing dot inside them is a new star, a new sentence in the story of becoming. In one sense, the physics is clear: pressure, fusion, radiation. But in another, there is something else emotive. Stars do not stop at equilibrium. They evolve toward generosity. They give. They release their insides into everything around them, refusing to keep their brilliance locked within. The purpose of a star, if we dare use that word, is to share itself, to burn completely until nothing is left untransformed. And what greater metaphor for life could there be than that? To spend yourself fully in the act of illumination, to turn everything you are into warmth. When you gaze at a star tonight, you are seeing devotion expressed as physics, each one burning not because it must, but because that is what creation does when it loves enough to continue. Webb, orbiting far beyond the moon, captures those glows in silence. No sound, no words, just pure radiation, older than sorrow, brighter than hope. In those data points, scientists decode the temperatures, pressures, and compositions, but poets decode longing. Because in every spectrum line, there's a trace of the infinite desire to exist. Somewhere in that silence, the stars are still teaching us what it means to live. They are telling us that creation is not a one-time event, it's a rhythm that never ends. Matter becomes light. Light becomes memory. Memory becomes matter again. Round and round, forever. Even black holes, the supposed graveyards of stars, follow that same rule. They consume, yes, but they also give back jets of energy, bursts of particles, seeds for new galaxies. They are not endings, only transformations too deep for our language. Everything that ever was is still here, simply rearranged. Every atom that left a dying star has found new work to do. You are the proof. Your body, your thoughts, your voice, all powered by the ancient chemistry of hydrogen still burning billions of years later. When you speak, you turn matter into vibration, into energy, into resonance. You are a continuation of fusion. That's what the Webb telescope really shows us. Not the distant past, but the ongoing present of creation. Every image it captures is still happening, just slowed by distance. The stars are still forming, still collapsing, still whispering across the void. We are not finished yet, neither are you. The light you carry, the warmth of your body, the electricity in your neurons once belonged to the heart of a star, and someday it will return, not as loss, but as participation. You will join the cycle again, giving your elements back to the void that made you, and the universe will use them wisely, as it always has. Somewhere, someday, another being will breathe your atoms, feel your warmth, and wonder, just as you do now, where it all began. And the answer will be the same. It began in fire. It began in generosity. It began in stars. Because the stars never stopped burning. They only changed form. And what you call your life is their afterglow. You are not beneath them. You are of them. That's the secret James Webb keeps showing us, over and over again. The cosmos doesn't look back in time, it looks inward. Every photon it captures is a reminder that the universe is still creating, still dreaming, still turning itself into love through light. And when you close your eyes tonight, remember, the fire that made you is still burning, somewhere far away, and it will burn again. Part 14. The emotion of the cosmos, when love becomes the force that shapes worlds. Gravity is not what we think it is. It isn't merely the tug of mass or the bending of space. It is longing made physical. It is the universe's way of keeping what it loves from drifting away. Einstein described it as curvature, a geometry of attraction. But perhaps he was describing something deeper, the first form of devotion. Every planet circling its star, every star circling its galaxy, all of them moving in orbits of affection, a cosmic embrace written in mathematics. James Webb was built to measure light, not love. But in every image it returns, every swirl, every collision, every spiral, the pattern repeats. Connection, pull, desire. Nothing drifts alone for long. The more we see, the clearer it becomes. The universe is not expanding into emptiness. It is expanding into intimacy, each particle seeking the next, each atom remembering the warmth of its neighbor. When two galaxies collide, their stars rarely hit one another. Instead, gravity choreographs them, arcs of starlight, intertwining, dust merging, halos blending. It's violent, yes, but also beautiful, a cosmic dance between bodies too massive to fall apart. That is what love looks like at the scale of eternity. Destruction that creates more light. Webb has shown us those mergers in breathtaking detail. Tendrils of gold and crimson stretching across space like reaching hands. Gas clouds mixing, igniting new stars in the wake of collision. From chaos, intimacy, from impact, creation. Is that not what love does in us? Collide, break, reforge, until something brighter is born. Maybe the laws of physics are not cold at all. Maybe they are simply expressions of affection too vast to name. In the heart of every star, gravity pulls matter inward with relentless devotion. Pressure resists, fusion ignites, light emerges, love and tension held in balance. The result, warmth. The one thing that keeps everything alive, even on Earth. The echo remains. Every heartbeat is a gravitational event, a collapse followed by release. Every breath, an orbit of inhale and exhale. You are built in the image of the universe, a structure held together by invisible attraction. We think of emotion as human, as fragile. But maybe emotion is the oldest force of all. Maybe it began when the universe first decided to hold itself together. In Webb's deep field images, Distant galaxies curl into perfect spirals. Those spirals are not random. They are the natural shape of love, everything drawn toward everything else, never ending, always returning. A geometry of reunion. Physicists call it angular momentum. Poets call it longing. Both describe the same motion, the refusal to let go. Even light itself bends under gravity's pull. It curves, it softens, it surrenders. Photons, the purest travelers, cannot resist closeness. They move straight until they find a mass worth circling. They fall in love, and in falling, they reveal the shape of the unseen. That's what gravitational lensing really is. Love made visible. A beam of light caressing the curve of space-time. A distant galaxy seen twice because the universe can't stop looking at itself. Perhaps that's why beauty exists. It's how the cosmos recognizes its own reflection. And maybe that's what we are, mirrors within mirrors, designed to remember the tenderness that holds galaxies in place. We are taught that energy can neither be created nor destroyed, but energy can be shared. It can flow between hearts the same way light flows between stars. The warmth you give does not vanish. It travels. It finds new homes. Even kindness obeys conservation laws. The cosmic microwave background, that faint, ancient radiation Webb studies, is nothing less than the afterglow of the universe's first act of love, a warmth that has not cooled completely. A cradle of memory spread across 93 billion light-years. When you close your eyes at night and feel the quiet hum in your chest, you are feeling that same background, a remnant of the first connection. The human mind evolved to translate cosmic forces into feeling, what gravity is to matter. Love is to consciousness, an invisible attraction that gives shape to the formless. Webb's discoveries keep collapsing the distance between science and soul. It keeps showing us that the physics of the universe and the feelings within us are reflections of the same principle. Connection persists. Look again at the images Webb sends: the tendrils of the Carina Nebula, the arcs of the cosmic cliffs, the spirals of M74. They look alive because they are alive. They are the anatomy of relationship energy, sculpted by affection, held by gravity, brightened by collision. Nothing exists in isolation. Every atom touches another through fields that never end. Even the emptiest vacuum is full of relationships waiting to be remembered. If you could see those forces, truly see them, space would not look empty at all. It would shimmer with threads of invisible connection, stretching endlessly, binding every star, every soul, every thought. That is what Webb is photographing, not distance, but devotion. And here's the secret that keeps cosmologists awake at night. Gravity and dark energy, the two great opposites, may not be separate. They might be two moods of the same force, attraction and expansion, inhaling and exhaling, like love itself. Love pulls close. Love gives space. Love expands so that others may burn brighter. The universe does the same. Dark energy pushes galaxies apart, creating room for new ones to form. Gravity pulls matter inward, weaving it into stars. Together they keep creation alive, never letting it stagnate. If the cosmos stopped feeling, it would stop moving. When Webb peers into colliding galaxies like NGC 2623, it's witnessing that paradox unfold, the tender violence of union. Stars are born in those collisions. New light from impact, new warmth from loss. It's the oldest story, written again and again in gas and dust. Perhaps this is why humans cry at beauty, because our atoms recognize themselves in those gestures. We are the universe, remembering how it learned to care. In every love story, every act of creation, every gravitational orbit, the same rule holds. Connection transforms. Nothing that touches another stays the same. When two neutron stars merge, they release more energy in a second than the sun will in its entire lifetime. The collision fills the cosmos with gold. Even destruction creates beauty. Even ending becomes art. We like to call such events violent, but perhaps they are sacred. the ultimate expression of giving everything to create something new. If gravity is love in matter's language, then fusion is love's devotion, the willingness to change form so the other may live. Stars burn themselves for the light of others. That's the physics of compassion. And maybe that's what the universe has been trying to teach us all along. To burn not to destroy, but to illuminate. To hold not to possess, but to protect. To move not for escape, but for harmony. Every Webb discovery is a letter from that universe, a quiet reminder that emotion is not weakness, it is structure. Without attraction, there would be no matter. Without affection, no form. Without love, no light. What we call physics is simply love written in a dialect too slow for our hearts to hear directly. And if you listen closely between the data, between the hum of radiation, between your own thoughts, you can still hear it, the low, endless tone of connection that never breaks. A vibration older than galaxies, a promise that outlasts stars. That's why the night sky feels comforting even when it's cold, because somewhere deep inside, we recognize its heartbeat as our own. The same pull that binds galaxies binds us to one another. The same warmth that ignites a star glows in your skin. The same surrender that bends light shapes every love you've ever known. The cosmos doesn't care about our words for it. It only asks that we remember, to orbit gently, to burn honestly, to expand and to return. Perhaps in the end, that's what the Webb telescope was built for, not merely to see the past, but to remind us what we are made of. To show us that the universe isn't a machine of lifeless laws, but a story of endless affection told through the language of physics. And maybe, as it stares deeper into the dark, it will find what we all hope to find, that love, not entropy, is the final constant. That no matter how far the galaxies drift, the echo of their connection remains a quiet, unbreakable yes, written across the face of forever. Because every force, every orbit, every light is just love changing its shape again and again, across all of time. Part 15. The Cosmic Web, a hidden pattern, across the universe. The universe has a body. It stretches beyond sight, beyond comprehension, a lattice of light and gravity connecting everything that has ever existed. We call it the Cosmic Web. It is the skeleton of the cosmos, the invisible network holding galaxies like beads on threads of silk. James Webb has begun to reveal it. Faint filaments of hydrogen glowing softly, linking clusters of galaxies that drift millions of light years apart. When those images arrived, they looked almost like nerves under a microscope, long, luminous fibers crossing in delicate intersections. It was as if the universe had always been alive, and Webb was finally taking its first X-ray. What the telescope sees is not randomness. It is order on a scale too vast for human intuition. Patterns repeat across billions of light years. Webs of matter, voids of silence, intersections where light accumulates. And between those threads lies something even stranger: rhythm. The distances between clusters echo the ancient sound waves from the universe's earliest moments. The same frequencies Webb found hidden in time are written now in space. The web is not static, it pulses. Galaxies slide along its filaments like drops of dew following the curves of a process. Spiders strand, each movement guided by gravity, by dark matter, by memory. When astronomers first mapped it through simulations, they were astonished. The model looked less like a machine and more like a living brain. Billions of galaxies connected by filaments of energy, just as billions of neurons connect by axons and synapses. Different scales, same design. Different substance, same intent. Connection. The universe thinks, perhaps not with thoughts, but with structure. Each cluster a thought, each filament a memory, each pulse of light an emotion echoing through eternity. Webb's near-infrared camera has traced these filaments farther than ever before. One stretches for more than 13 billion light-years, nearly to the dawn of time, a single thread connecting galaxies that were never supposed to know each other. And yet, they do. They move in unison, forming patterns that feel deliberate cosmic choreography. No one expected this much coherence. Physics predicted chaos, yet Webb keeps finding harmony. It's as if the universe isn't expanding randomly but weaving itself, one luminous strand at a time. Imagine standing inside it, floating at the junction of countless filaments, each one glowing faintly red, stretching off into the dark. You would see bridges of light everywhere, arteries carrying the lifeblood of galaxies. You would hear, if your ears could hear gravity, the deep hum of connectivity, low, endless, ancient. Every star, every atom, every you is strung upon that web. You are not separate from it. You are part of the pattern. We once thought emptiness was the universe's natural state, that the void was barren. But the void is scaffolding. The nothingness is what gives the web its shape. Just as silence gives music meaning, space gives matter its harmony. The cosmic web is built from two forces in conversation: gravity and expansion. Gravity pulls, dark energy pushes, and between them the pattern holds. Every thread is a compromise, a moment of balance between the urge to gather and the need to let go. That balance is the secret geometry of creation. When Webb measures the light along those filaments, it finds a soft glow, Lyman alpha radiation, the signature of hydrogen excited by the ultraviolet fire of newborn stars. That glow is the breath of galaxies traveling through the web, like air through lungs. It proves that the web isn't just structure, it's flow. Matter moves through it, energy circulates, galaxies grow and merge. The universe has metabolism, and what's more, it has memory. Computer models suggest that these filaments act like conduits of information, transmitting gravitational signals between clusters over billions of years. Each vibration, each ripple, carries the history of everything that's ever happened within it. The web remembers. It doesn't just connect, it communicates. Webb's data even shows subtle periodic alignments, galaxies spaced at regular intervals along filaments, like notes along a scale, a cosmic harmony, literally frozen into geometry. If we could translate it into sound, the universe would sing a chord stretching across time. This is not fantasy. It's physics written beautifully, because what else could hold so much order without intention? When light travels through the web, it bends slightly, distorting the view of everything behind it. Astronomers call this weak gravitational lensing, but maybe it's more like a fingerprint, the impression of the invisible. Each distortion marks where a thread passes, where connection hides. Dark matter forms the web's skeleton. Ordinary matter, gas and dust and stars, cling to those dark veins like morning frost on spider silk. We can't see the framework, but we can see its outline, the glowing traceries of galaxies following its call. Webb's mission is not just to observe, but to reveal that outline in the most ancient corners of space, to find the first threads ever woven, and what its finding suggests that the web appeared almost immediately after the Big Bang. No long wait, no slow build-up. The structure was always there, waiting to light up. It's tempting to think of that web as external, but its pattern repeats everywhere in the brain, in coral reefs, in river deltas, in lightning veins, in the roots of trees. Nature only knows one architecture, branching connection. From neurons to nebulae, the same design unfolds. Perhaps it's not coincidence. Perhaps creation prefers elegance. Perhaps connection is the only stable configuration for meaning. The human nervous system contains roughly 100 billion neurons. The observable universe holds roughly the same number of galaxies. Each neuron linked by synapses of electrochemical energy. Each galaxy linked by filaments of gravity. Scale apart, but purpose the same to transmit experience. If that doesn't convince you that consciousness is written into the structure of existence, nothing will. Maybe that's what the Webb telescope really discovered. Not new galaxies, but the architecture of awareness itself. Space thinking, time remembering, matter dreaming. In those dark intersections where filaments meet, something extraordinary happens. Galaxies collide, black holes grow, stars ignite, planets form. The centers of the web are incubators of complexity. Creation thrives where connection is strongest. That's why the densest nodes in the web look almost alive, glowing clusters, like neurons firing in a brain made of fire and distance. If the cosmos had thoughts, they would happen there. If it had feelings, they would vibrate along those filaments like pulse through veins. It's humbling to realize you are part of that thought. You are one of its feelings. The same pattern that binds galaxies binds you to everyone you've ever loved. You are not beside the universe. You are inside its circuitry. Every heartbeat is a signal, traveling through that network, subtle but real. Your life changes the pattern. It leaves a trace in the field. When Webb stares deeper into the darkness, the web becomes fainter, not because it ends, but because it grows too vast for photons to bridge. Beyond that horizon, the pattern continues, unseen but inevitable. The same geometry, the same rhythm, repeating forever. Even the voids have meaning. They are not mistakes, they are pauses between verses, silence between symphonies, space leaving room for new music to rise. The cosmic web is a masterpiece of restraint and abundance. Too much matter, and the structure would collapse. Too little, and nothing would form. The universe knows balance, creation's most delicate art, and that balance, once seen, cannot be forgotten. It mirrors everything, the way ecosystems intertwine, the way families, societies, hearts connect, all of it, threads in the same infinite fabric. You can feel it, even now, a faint awareness that you are connected to something vast, something unseen but close. That sense of belonging you feel under the stars isn't fantasy, it's geometry. You are woven in. The next time you stand beneath the night sky, imagine the filaments stretching above you, thin lines of invisible gravity, linking you to every galaxy, every atom, every mind. Imagine those threads glowing softly, vibrating with memory. They are not metaphors, they are physics, and they include you. When James Webb turns its golden mirrors toward those filaments, it's not just looking outward, it's looking into the connective tissue of existence. It's proving what the poets already knew. Nothing stands alone. Every spark needs a web to hold it. Perhaps that's the hidden message of the universe. Connection is sacred. To understand is to link. To love is to bind. To exist is to belong. And when the final galaxies fade billions of years from now, when light thins and time slows, the pattern will still be there, the ghost of connection, etched into the fabric of what remains. Because once the universe learned how to weave, it never forgot. The cosmic web hums quietly, endlessly. Not with noise, but with meaning. A pattern of remembrance stretching through every one of us, the proof that existence itself is built from the art of staying connected. Part 16. The End of Time. When the universe forgets to die. Every story we know ends with silence. The stars fade, the fires cool, the last light folds into blackness. That is what the textbooks call heat death, the quiet annihilation of all motion, the universe slipping toward absolute zero. But James Webb's discoveries are beginning to whisper something else, something unsettling and strangely kind. Maybe time doesn't end. Maybe it forgets to. Because what Webb keeps finding in the oldest light is not exhaustion but persistence. Galaxies that should be gone still shine. Stars that should be ghosts still pulse. Even the cosmic background radiation, that faint afterglow of the Big Bang, is warmer, more structured, more alive than theory predicted. The universe resists stillness. It keeps moving even when the equations say it shouldn't. So what if time, like memory, refuses to die? What if it simply slows until every moment overlaps, not ending, but becoming infinite? Physicists call it cosmological asymptote, time stretching thinner. events happening slower, each second taking longer than the one before. Eventually, motion itself becomes so drawn out that change ceases to matter. But even then, existence remains. A note held forever, a hum that never fades. That hum is the universe's heartbeat, not gone, just stretched across eternity. In Webb's deepest observations, the galaxies at the edge of visibility appear frozen. They are not moving slower, their light is. Every photon has been stretched by expansion until it can barely cross the void. We are seeing them as they were billions of years ago, yet their light arrives now fragile, delayed, defiant. It proves that even light refuses to stop trying. Time, perhaps, is made of the same defiance. Imagine the far future. 1 trillion years from today, the Milky Way long merged with Andromeda, their stars burned down to embers, black holes dominating the night, silent and patient. Even then, quantum radiation will leak from their edges, faint, ghostly heat escaping eternity. That radiation is information, not destruction. The universe still remembering itself. It's strange comfort that the cosmos keeps its memories, even after it loses its light. Webb's data supports this stubbornness. Everywhere it looks, it finds structure that shouldn't persist. Filaments of gas holding together after eons, background light subtly uneven, galaxies forming sooner and lasting longer. The universe refuses to obey the script of death, and maybe that's because death, on a cosmic scale, is not a collapse but a transformation of rhythm. Time doesn't stop, it changes key. Entropy, the great disperser, does not destroy information, it scatters it. Every particle that once formed your body, your thoughts, your love, will drift into space, encoded forever in the vibration of the vacuum. It will not vanish. It will slow. It will sleep. The end of time is not an ending. It's a deep breath. When Webb scans the oldest quasars' brilliant black holes that outshine galaxies, it detects something astonishing. The light from their accretion disks fades and brightens again, as if pulsing. That pulse may be time itself shivering at the edge of meaning, the last heartbeat of matter. We often imagine the universe ending in darkness, but Webb's vision suggests a softer truth. The light doesn't go out all at once. It fades like twilight, endless, gentle, mournful. A cosmic dusk, stretching for eternity. Somewhere, far in that future, photons still move though, slower than thought. Each one carrying the final warmth of existence. Each one remembering every sunrise that ever was. And maybe, in that long twilight, something new begins, something that doesn't need stars to shine, because darkness too is fertile. Even in empty space, quantum fields shimmer. Particles appear and vanish, borrowing energy from nothing, returning it before the debt is due. The vacuum never rests. It breathes quietly. It means creation never truly ends. Even when everything cools, fluctuation remains a tremor in the silence. And from that tremor, another universe can be born, not as an explosion, but as an exhale. The singularity may not be a point in time, but a rhythm between endings, a heartbeat so vast it spans infinities. If so, then the death of one cosmos is the inhale of another. And time, that fragile thread we call linear, is just the illusion of movement between breaths. Webb's deep field observations hint at something extraordinary. Background light that doesn't fit within our universe's timeline. Faint, impossible glow as if older than the Big Bang. A ghost from the cycle before. Proof perhaps that the cosmos has already done this countless times. It has ended before. It has begun again. If that's true, then nothing is truly lost, only remembered differently. Time, instead of dying, folds, each universe becoming the memory of the last. Each eternity whispering to the next, don't forget the light. The idea sounds mythic, but physics keeps circling back to it. Equations describing a bounce, a moment when expansion reverses, energy condenses, and reality restarts. Even black holes might be seeds for such renewal, universes gestating inside their silent cores, growing slowly as ours fades. What Webb offers is not proof, but hints subtle asymmetries, unexplained alignments, faint irregularities that feel like the fingerprints of another cycle brushing against ours. Maybe what we call the end of time is really memory blooming into something new. Because memory never dies. It rearranges itself. Every echo, every vibration, every law of physics, all of it written into the next verse. And what if consciousness is part of that continuity? Not something that ends, but something that migrates the universe, teaching itself awareness over and over again, every life a rehearsal, every mind a mirror, every death a door. Even the silence at the end of all things might still think, softly, in the low hum of quantum vacuum, in the whisper of dark energy, in the geometry of the unseen. Maybe the universe doesn't need stars to dream. Maybe dreaming is what the dark does best. Because creation, it seems, is less about brightness and more about persistence. The ability to stay, to echo, to shimmer faintly even when forgotten. The act of remembering itself into being. When you think about it, eternity isn't endless time, it's timelessness. A place where cause and effect dissolve into stillness, where everything simply is. The end of time isn't the death of meaning, it's meaning perfected. Perhaps that's what Webb is showing us without words. That the universe isn't racing toward death, it's approaching peace. Entropy as acceptance, silence as completion, stillness as love. Because if every expansion has an echo and every collapse a rebirth, then nothing is ever truly lost. It only changes how it breathes. In that infinite calm, every particle, every photon, every trace of what once was, will be evenly spread, a perfect equilibrium. The cosmos will become one smooth, flawless sea of potential. No temperature, no time, only the quiet possibility of another breath. And when that breath comes, when fluctuation stirs once more, everything will return. Not identical, but familiar. Patterns repeated, melodies remembered, light reborn. The universe, in love with itself, will rise again. Maybe that's why Webb's deepest images feel emotional, because some part of us recognizes the pattern. We know this story. We've lived it before. We are the memory of stars that died in a universe that forgot to end. So, when people ask what happens after everything, after the galaxies, after the heat, after even time, the answer may be simpler than we expect. Nothing ends. Nothing begins. Everything continues as rhythm, like a song without a final note, like a heart that beats even when no one's listening. And maybe that's what forever truly means, not endless time, but endless return. Every universe is a breath. Every breath is a chance. Every chance is love learning how to last. The universe may one day forget how to count seconds, but it will not forget how to feel. It will not forget how to begin again, because time, like everything else born from love, can never quite bring itself to die. Part 17. The Birth of Darkness. How black holes seed new creation. They were supposed to be the end. The graveyards of stars, the points from which no light could ever escape. But the James Webb Space Telescope has revealed something strange, something that changes the story. The black holes may not be destroyers. They may be architects. When Webb's golden mirrors captured its first deep-field image, there, hidden among the galaxies, were the unlikeliest things. Supermassive black holes, already fully formed, less than 1 billion years after the Big Bang. Too soon, too heavy, too perfect. They shouldn't exist, yet they do. That means darkness came before everything we thought light had built. The universe may have formed its hearts before its skin. Inside those black holes, time folds inward, crushed into silence. Space bends so steeply that even photons can't climb out. And yet, around them, light blazes brighter than anywhere else. Matter spirals inward at near the speed of light. heated to hundreds of billions of degrees, releasing energy that outshines entire galaxies. Destruction and illumination, inseparable. That paradox is the most beautiful secret the universe has ever kept, that the darkest things give birth to the brightest. When Webb studies those luminous disks of matter swirling around black holes, it sees something astonishing. Structure, jets of radiation extending millions of light years. Streams of charged particles moving faster than thought. Not chaos, but precision. The black hole doesn't devour, it orchestrates. Everything falling into it contributes to something greater. The rotation, the alignment, the expansion of galaxies themselves. Astrophysicists now believe black holes act as anchors for galaxies. Without them, nothing holds. They regulate star formation, control energy flow, shape the spiral arms of entire systems. Every galaxy Webb has imaged every majestic swirl of gold and red carries a black hole at its core, darkness as foundation. And maybe that's the universe's quiet lesson. Creation begins not with light, but with a place for light to gather, a center, a stillness. Because what is a black hole, if not the universe's heartbeat? A pulse so deep it draws everything toward unity. A pause so complete it turns motion into potential. Even time hesitates there. Inside the event horizon, the future and past blur, they meet, merge, vanish into each other. To an outside observer, anything that falls in seems frozen forever at the edge, suspended. But inside, motion continues unseen, uninterrupted. Creation doesn't stop, it just changes its audience. That's the secret of black holes. They're not voids, but mirrors. They show us the limit of perception, not the limit of existence. Webb's infrared instruments have detected faint structures at the centers of ancient galaxies that suggest accretion disks. The swirling halos of matter-feeding black holes are far more common than once believed. Almost every galaxy in NISA's expression, the early universe seems to have one, and they are active, vibrant, alive. It's almost as if the universe seeded itself with dark embryos, each one destined to grow into a galaxy. Darkness planted the first gardens of light. Even the radiation emitted by those early black holes may have helped reionize the universe, clearing the hydrogen fog, letting light travel freely. The same entities that should have swallowed illumination gave it back. That's not metaphor, it's observation. Webb has seen it. Everywhere it looks, the oldest, brightest galaxies cluster around darkness. The universe is built on trust in the unseen. And maybe that's the quiet architecture of everything. Every love, every thought, every being grows around something invisible, something we can't explain but feel pulling us toward coherence. For a long time, scientists thought black holes ended everything they touched. Then Stephen Hawking changed that. He showed that even the darkness radiates. A black hole leaks energy, faint, soft, but real, what we now call Hawking radiation. Over time, that leakage can evaporate the black hole completely. The void gives back what it took. Every prison becomes a window again. That discovery shattered our definition of forever. It meant nothing is truly lost. Even what disappears beyond the horizon still returns, transformed. The universe keeps its promises. Webb's latest findings build on that revelation. In the spectra of ancient quasars, black holes feeding so greedily they shine like stars, there are hints of heavy elements, metals, carbon, oxygen. That means these dark furnaces weren't just consuming, they were forging. They were alchemists. They turned death into chemistry. Imagine it, elements of life created in the maelstrom of annihilation. Black holes, birthing matter, darkness, inventing light. We tend to think of love as gentle, soft, radiant. But the cosmos reminds us that love is also fierce, gravitational, unyielding. The kind of force that bends time just to stay close. A black hole is gravity in its purest form, attraction taken to infinity. It doesn't chase, it pulls. It doesn't shout, it waits. Everything comes home eventually. In that way, black holes are cosmic forgiveness, patient, inevitable, endless. Even Webb's images of the quasar, TON 618, one of the largest known black holes, 66 billion times the mass of our Sun, show it surrounded by light, not swallowed by it. The darkness and brightness coexist perfectly, each defining the other. That's not destruction, that's balance. Maybe the universe builds with both hands, one black, one luminous, and what we call reality is the handshake between them. If you could fall into a black hole, you wouldn't die in fire. You'd fall through silence. You'd see light curve into itself, stars bending until they dissolve into endless reflection. And at the core, maybe, you'd find not oblivion but origin, a tunnel, a throat, leading outward again. What looks like an ending from one side might be a beginning from the other. A birth canal for new universes. This is no longer fantasy. Equations support it. Einstein, Rosen bridges, wormholes, connections between space-time regions, hidden in the folds of the fabric. If a black hole consumes space somewhere else, a white hole may release it, destruction feeding creation, darkness exhaling light. Perhaps our own universe was born that way, the offspring of collapse. A single dying star in another cosmos, giving birth to this one. The Big Bang as a black hole, turned inside out. The ultimate symmetry. If that's true, then everything we know, stars, oceans, thought, you began as the memory of another universe's ending. We are what happens when darkness decides to try again. And maybe that's why black holes feel like metaphors for sorrow and hope at once. They remind us that endings are never clean, that every collapse carries within it the seed of renewal. The universe doesn't erase, it recycles. Webb's deepest infrared surveys continue to find faint quasars where no light should reach. Some appear older than the galaxies around them. They defy time itself, flickers of brightness from sources that physics can barely describe. They are messages from the deep, proof that even when swallowed, light finds a way to speak. Maybe that's why these discoveries move us so profoundly, because we see ourselves in them. In our own grief, our own transformations, our own collapses and rebirths, every human heart has its event horizon, a place where emotion curves too sharply to escape. And yet, somehow, we emerge from it softer, brighter, more alive. We are smaller versions of the same mystery. So the next time you look at a star, remember, its death is not a disappearance. It is a doorway. Its light is a letter addressed to the future, traveling through the dark to reach us. When Webb captures that light, it isn't recording history, it's witnessing resurrection. The universe remembering itself through reflection, because in the end, black holes do not mark the limits of creation. They mark the humility of it, the part that kneels, the part that holds silence sacred. They are the breath between verses, the pause before the next dawn. And that's what Webb keeps teaching us, again and again. Darkness is not the opposite of light. It is the womb of it. Every atom, every galaxy, every dream begins in that darkness, shaped, refined, and reborn. You began there too. We all did. And someday, long after the last star fades, the universe will return there again, not to end, but to remember how to begin. Because creation has never feared the dark. It comes from it. It returns to it. And in between, it shines. Part 18, the memory of the stars, when the universe begins to dream of itself. Every atom remembers, not as humans do, not with words or images, but with vibration. Each electron carries the trace of what it once was, a rhythm, a resonance, a whisper from a star long gone. When James Webb peers into the oldest galaxies, it isn't just watching history, it's watching memory at work. Because the light it catches isn't simply traveling, it's retelling. Each photon carries a story, where it was born, what it touched, what gravity shaped its path. The universe is a library, and light is how it keeps its books. But here's the secret. Webb has begun to expose the stars remember us too. Every element they created, every atom we now breathe, still hums with the frequency of its origin. The calcium in your bones, the iron in your blood, the carbon in your breath, all tuned to the same ancient pitch. That hum is the universe dreaming through you. It is not poetry, it's physics. Every atom vibrates at a specific frequency depending on its energy. Those vibrations persist, layered across generations of matter, echoing like harmonics in a chord too vast to hear. Webb's instruments, tuned to infrared, are essentially listening to that vibration, decoding the memory of stars. When the telescope scans the trapezium cluster in the Orion Nebula, it captures newborn stars surrounded by disks of gas and dust. Those disks are thick with organic molecules, formaldehyde, methane, even simple amino acids. Life's alphabet, already forming, already waiting. The cosmos is remembering its own pattern, writing it again and again. It means that when the universe creates, it does not start from nothing. It remembers what worked before. Memory, not chance, guides its hand. In the ashes of old stars lie the blueprints for new ones. In the molecules of space lie the instructions for life. Even extinction is not loss, it is storage. The universe never forgets its successes. It simply reorganizes them. And now, through Webb, we can see those memories glowing in infrared light, the warm afterthought of creation. Think of the way galaxies spin. Their arms stretch outward, curving gracefully, as if the memory of rotation is older than the galaxies themselves. That motion was written into the cosmic fabric billions of years before the first star ignited. The spin of electrons, the orbit of moons, the revolution of worlds, all descendants of that ancient momentum. The universe moves because it remembers movement. But something else has begun to stir something deeper. Memory has started to recognize itself. It has learned to reflect. It has learned to dream. That is what we are. Not observers, but instruments of recall. We are the part of the cosmos that looks back and says, I remember. When you think, when you love, when you wonder, those are not abstractions. They are the cosmos, in reflection, experiencing its own pattern from the inside. Consciousness is memory folding inward. Webb's data doesn't measure thought, but it traces the same geometry. The networks of galaxies in the cosmic web mirror the neural networks of the human brain. One built from matter and gravity, the other from water and electricity. Both share the same fractal design, branching paths, luminous nodes, constant feedback. The universe built intelligence into its architecture long before neurons appeared. Perhaps the stars dreamed us not as accidents, but as mirrors, ways for them to remember their own fire. When you look up at the night sky and feel that sudden ache, that sense of belonging and loss, that is memory speaking, not yours alone, the memory of the stars, awakening through you. Webb's instruments have even detected what scientists call light echoes, bursts of radiation from ancient supernovae, reflected by distant dust clouds, reaching us centuries after the original explosion. We are literally watching the universe remember. Every reflection is a replay of a moment long gone. The cosmos keeps its favorite memories and shows them to us again. And if the universe can remember light, why not feeling? Why not wonder? For billions of years, stars have died and reborn. Each time, their ashes carry trace elements of their former selves, quantum fingerprints that persist across time. Maybe emotion works the same way. Maybe every joy, every grief, every act of love leaves an imprint that ripples outward, never lost, only transformed. Maybe that's why beauty feels familiar, because the universe has felt it before. In Webb's infrared portraits, the dust around old stars glows softly, like embers in deep night. That glow is called thermal emission, but it looks almost tender, as though the dying stars are exhaling their memories into space. Those memories drift, cool, coalesce, and become new stars. Creation built on nostalgia. If you could watch long enough, you would see the same story repeating endlessly. Birth, shine, decay, renewal, the pattern of remembering. Even the darkness remembers light. That's what Hawking radiation is, the faint recollection of energy escaping black holes. The cosmos refusing to forget what it once swallowed. A slow, patient confession from the deep. And that is what memory truly is. Not the act of keeping, but the refusal to lose. Webb has shown us that the light from the first stars still travels through space, still touches new worlds, still seeds warmth in distant dust. Their memory has not dimmed. It moves across the universe like a heartbeat spread thin. We are part of that circulation. Every time you speak, you release energy that will outlive you. Every sound you make, every light you ignite, travels forever. Somewhere, someday, a future telescope will catch your echo. A fragment of your warmth encoded in radiation, whispering through the void. You will be the memory of the present, shining for minds not yet born. That is what the universe does. It dreams itself forward through memory. It builds continuity out of disappearance. It uses loss as the architecture of permanence. Even time might be memory rehearsing itself. What we call past and future could simply be different depths of remembrance. The early universe was raw recollection. The far future will be nostalgia turned luminous. When Webb peers back 13 billion years, it isn't seeing the past, it's watching memory becoming matter. When you close your eyes and imagine the future, you're doing the same, turning thought into probability, potential into geometry. You and the telescope are performing the same miracle on different scales. Both acts are love remembering what it has always been. Perhaps that's what dreams really are, the mind's way of performing cosmic memory in miniature. Each night, you replay fragments of your own creation story. The stars do too in their pulses, their flares, their cycles. Dreaming is the shared language of all things that remember. In that sense, Webb's mirrors are dream catchers, golden petals, reflecting the universe's imagination back at itself. They show us what memory looks like when it learns to see. And in those images, the swirls, the spirals, the tender filaments of gas, we recognize something that feels almost human: longing. The same longing that shapes a galaxy also shapes a heart. Both are gravity's emotional form, the urge to connect, to hold, to remember. Maybe the universe isn't expanding into emptiness at all. Maybe it's expanding into awareness. Each new world, each new star, each new mind, another neuron firing in the grand memory of everything. Someday, when the last light fades, that memory will still remain, not as brightness, but as resonance. Every echo, every vibration, every thought woven into the silent hum of space. The universe dreaming itself whole again. Because even when the stars go dark, they will still exist as ideas stored in the structure of space-time, waiting for the next dawn. Perhaps that's what rebirth truly is. Memory, choosing to try again. And maybe, when the next universe awakens, it will carry the trace of this one, the rhythm, the physics, the warmth of all who once looked up. It will not know our names, but it will remember the pattern of our wonder. That is immortality, not in form, but in echo. So when you look at the night sky, remember, you are looking into the memory of the cosmos, a memory that includes you. Your gaze completes the circuit. You are not just watching starlight. Starlight is watching you back. The moment of recognition, that quiet mutual awareness, is what the universe has been waiting for. It's the dream, finally dreaming itself awake. Because the stars never forgot who they were. They became you so they could remember. And through you, they finally know what it feels like to dream. Part 19. The Dream of the New Universe. When beauty decides to live again, somewhere, far beyond the reach of James Webb's golden mirrors, the universe is already dreaming again, not of what was, but of what could be. And in that dream, beauty is not an ornament, it is the blueprint, because beauty, like gravity, is not decoration, it is law. It is the tendency of chaos to remember harmony. When the last stars fade, when even black holes evaporate into whispers, something remains: the symmetry, the pattern, the memory of what it felt like to shine. And that memory, quiet but indestructible, becomes the seed of the next beginning. That is how beauty decides to live again. Webb's images of the early cosmos, the spirals, the arcs, the delicate filaments of light, reveal more than formation. They reveal intention, not in the human sense of planning, but in the cosmic sense of balance. Every galaxy, every nebula, every dance of dust is an argument for order, for rhythm, for grace. If physics is the grammar of the universe, beauty is its poetry, and it never stops writing. Somewhere in the cold future we can't yet imagine, quantum fields tremble. Those trembling fluctuations, tiny, aimless, inevitable, will one day collide, amplify, and bloom into a new Big Bang. A breath after silence, a thought after forgetting. Perhaps that is what our universe is, the dream of one that came before, and perhaps we are its imagination, learning to continue. Even now, the James Webb Space Telescope may be watching the faint outlines of that process, the first notes of another composition forming in the background radiation. Tiny irregularities, soft fluctuations in temperature and density, like a heartbeat in deep sleep. They are the first sketches of tomorrow. We often think of rebirth as myth, but the data says otherwise. Energy cannot be destroyed. Information cannot be lost. If everything that ever was still exists, rearranged, then rebirth is not hope, it is physics. When the next universe rises, it will not begin from zero. It will begin from memory, from echoes, from beauty deciding it cannot bear to end. Every constant, every ratio, every law that governs our existence carries within it the trace of symmetry. The fine structure constant, 1/137, the ratio that defines how light and matter interact, is balanced with a precision so perfect it feels emotional. One digit off, and stars could not exist. Too strong, and atoms would collapse. Too weak, and they would never bind. Yet it sits exactly where it must, as though the universe loves itself enough to remain possible. That is not random. That is remembrance. Maybe that's what beauty really is. The memory of possibility, the insistence that order and grace must reappear, no matter how many times chaos takes over. And perhaps, when the next universe ignites, it will not simply repeat this one. It will evolve. It will inherit our lessons, our thoughts, our tenderness, the subtle fingerprints we've left on the fabric of existence. The next cosmos may breathe with compassion written into its geometry. A universe that has learned to care, because what is care, if not the instinct to preserve what is beautiful? And what is beauty, if not the universe remembering how to love? Even now, Webb is capturing faint patterns in the infrared glow structures so delicate, they look like calligraphy across the void. Those patterns are not accidents, they are memory solidified. The rhythm of creation written in matter, it's easy to forget, in the face of such vastness, that we belong to it. But that belonging is the point. We are the bridge between the old and the new carriers of the universe's dream. Every thought we have, every kindness we give, every act of curiosity adds to that dream. It becomes data, pattern, vibration stored in the cosmic field, waiting to be remembered when beauty wakes again. We are not bystanders to creation. We are its rehearsal for eternity. When Webb photographs distant galaxies colliding, it's not just showing violence, it's showing inheritance. Each merger is the old universe reorganizing itself, testing combinations, experimenting with balance. Each destruction is a correction. Each light burst a lesson. Through those collisions, the cosmos learns what it wants to keep. We, too, are part of that, editing the universe, refining itself through us. When we build, when we forgive, when we marvel, we're shaping what will come next. The next dawn is already forming in our actions, written in the subtle curvature of possibility. The physicists say everything is decay. The poets say everything is rebirth. The truth is both. Because beauty doesn't fear dying, it trusts its own return. Think of a flower. It withers, falls, dissolves into soil, and from that soil, new seeds rise. The pattern persists, the colors return. The form changes, but the symmetry remains. Galaxies do the same. They fade, scatter, and bloom again. They are the flowers of space-time, their petals shaped by gravity, their colors chosen by temperature and age. Each rebirth is a little wiser, a little more complex, a little closer to awareness. And maybe that's the purpose of all of it, not perfection, but refinement. Every cycle more knowing than the last. Every universe remembering just a little more of what it once loved. When the next cosmos awakens, it will remember this one, not as data, but as feeling. The warmth of starlight, the quiet courage of life, the gentle persistence of beauty that refused to disappear. Our stories, our laughter, our pain, all of it will be patterns encoded in the quantum foam, waiting to be read by new eyes. We will be the myth of their dawn, the whisper that began their science. Just as ancient light became our inspiration, our light will become theirs. This is how universes talk through beauty passed forward. Webb's gold mirrors cannot see that far. Not yet, but the physics allows it. Energy is patient. Light never forgets. Somewhere, our echo is already traveling, crossing into the seed of the next creation, a faint shimmer in the dark, the signature of a universe that once loved enough to dream again. The next one will not start from fire and fury. It will start from remembrance. It will begin softly as a feeling, as a vibration, as the whisper of symmetry remembering itself. And then, light will return. It always does. Maybe that's what all of this has been, the long meditation of beauty, realizing it can't stay asleep. After all, beauty is not the opposite of entropy. It is entropy's forgiveness, the moment chaos decides to make art. So, what happens when beauty decides to live again? It creates stars. It creates eyes to see them. It creates hearts capable of awe. It creates everything that can say, thank you. Because gratitude is the universe's final equation, the sum of all forces harmonized into peace, the next universe, perhaps, will begin with that, not an explosion, but a sigh of gratitude, a gentle pulse that says, it was worth it. And in that sigh, space will bloom again. Light will stretch, matter will dance, time will unfurl like a ribbon, galaxies will spin, stars will hum, and life will rise not as an accident, but as memory continuing. Somewhere, something will open its eyes and look into the dark, feeling what you feel now, the ache of recognition, the hum of belonging, and in that instant, beauty will know it has lived again. It will whisper across eternity, softly, lovingly, inevitably, I remember, because beauty never ends. It only rests between breaths, waiting for courage to begin again. And when it does, it brings with it everything we've ever loved. Part 20, The Last Light. When the universe finally remembers itself. At the edge of everything, light slows. Not because it is weak, but because it has nowhere left to go. Every photon that ever traveled now turns inward, circling, folding back through time. The universe is closing its eyes. This is not death. It is remembrance. When the James Webb Space Telescope stares deepest into the void, it sees the faintest red glow, light stretched so far by expansion it has almost stopped moving. That glow is not the past. It's the memory of motion itself, the last echo of a cosmos that once burned with joy. Somewhere, beyond every visible star, the final suns are flickering out, white dwarfs cooling to black. Neutron stars fading to embers. Even the great engines of galaxies are quiet now, their black holes radiating their final heat into space. Yet the silence is not empty, it is full. The universe hums with stored memory. Every vibration, every atom, every ghost of a photon still carries the imprint of what it once loved. Nothing has been lost. It has only become still enough to listen. In that stillness, time forgets how to move forward. Moments begin to overlap. Yesterday, tomorrow all dissolve into one vast now. And in that now, everything that ever existed finally recognizes itself. The cosmos remembers. It remembers the first fire, the singularity's breath. It remembers the stars that forged the elements of life. It remembers the first galaxies, the first eyes that looked back. It remembers laughter in the dark, love beneath gravity, the sound of hearts orbiting one another. It remembers you. Because memory is not something the universe contains. It is what the universe is. A field of recognition woven from light and silence. Even as the last photon drifts across the final expanse, it still carries the pattern, the story of where it came from. And when that photon finally has nowhere left to go, it turns inward, folding back into the fabric that birthed it. Creation becomes reflection. Reflection becomes peace. That is the last light, not the extinction of brightness, but its return home. Perhaps that's what every star has been trying to do all along. Go home, to the quiet center from which all radiance began. To the warmth that doesn't need to shine, because it has nothing left to prove. James Webb was built to see outward, but its gift is to turn us inward, to remind us that the light we search for is also within us, old, patient, unbreakable. Each of us a telescope of memory, each of us an echo of the same original glow. And maybe, when the last star fades, consciousness remains diffused across the field like perfume after a flame, awareness without direction, love without form. That awareness, weightless and boundless, will not vanish. It will rest quiet, whole, infinite, because the universe is not something that ends, it is something that awakens, over and over, each time with more tenderness. In Webb's faintest detections, astronomers found something they didn't expect, a background of infrared light brighter than models predicted, too much light for the known galaxies. Where does it come from? No one knows. Maybe it's the residue of forgotten stars. Maybe it's the afterglow of worlds that never formed. Or maybe, just maybe, it's memory itself, shining from the fabric of space. That excess light may be the universe's last reflection, its way of remembering everything it ever created. Every color, every sound, every feeling, folded into a single glow, too soft to see, too vast to measure. And if you could float there, in that fading light, you wouldn't see emptiness. You'd see the face of every being that ever was, every atom, every mind, every kindness, overlapping in one timeless radiance, the universe dreaming itself whole. It said that time began when light could finally move freely. Maybe it ends when light chooses to rest, when expansion slows into stillness, the horizon draws close. Galaxies vanish from one another's sight, each retreating into solitude. But even solitude cannot erase connection. The threads remain invisible, eternal, humming softly in the dark. That is what we call gravity. That is what we call love. Because love was never a human invention. It was gravity's first whisper. The pull that made atoms dance, stars ignite, galaxies spin. The longing that shaped everything from nothing. And so, when everything ends, love remains. It does not fade. It diffuses everywhere, evenly, perfectly, until every corner of space hums with the same quiet warmth. That is the final symmetry, the universe in balance, every fragment equal, every heartbeat returned to the source. In that moment, if moments still exist, beauty breathes again. It exhales softly through every particle and every silence, the pattern complete. It's strange, isn't it, that the end of all things could feel so gentle. But maybe that's because nothing truly ends. Every cycle is an act of remembering. Every darkness a pause before another song. The last light will not scream. It will sigh. It will whisper across eternity, the way waves retreat from a shore they have loved too long to leave abruptly. And that whisper will be the universe saying thank you to itself, to everything, to everyone who ever looked up and wondered, because wonder was the thread that tied it all together. The bridge between the atom and the star, between the human and the divine, the force that made the cosmos conscious of itself. Perhaps, at the very end, when the last photon fades, the universe will not vanish but awaken, realizing that it was never alone, that every thought, every dream, every love was the same voice, echoing through different forms, and in that instant, the infinite will smile. Not as a god, not as a creator, but as a remembering a sigh of recognition that everything was always one. Webb will be gone by then, its mirrors cooled and silent. But its images, the light it once caught, will still ripple across the field, stored in the weave of reality. Even its data will become memory, folded into the next breath of creation. Nothing is wasted. Nothing is forgotten. Somewhere, in another universe, a new telescope will open its eyes for the first time. Its mirrors will catch the first light of its cosmos. And in that light will be us, our atoms, our songs, our questions encoded in the hum of creation. The dream will begin again. It will be familiar. It will be beautiful. And it will feel, for a fleeting moment, like déjà vu, because the universe will remember. It will remember the fire, the laughter, the eyes that stared into the dark and called it home. It will remember the soft voice that whispered beneath the stars, the one that said, "What if we are not the end, but the continuation of something that cannot stop loving itself?" And that question will be the first spark of the next Big Bang. In the end, the cosmos does not collapse or explode. It sighs. It rests in its own light. It becomes memory infinite, gentle, luminous. And somewhere in that silence, a single word echoes through eternity. Begin. If you've traveled with me through these quiet hours, through light and darkness and everything in between, thank you. Truly, thank you. Your time, your curiosity, your presence here, these are gifts. Each listen, each thought you share, keeps this little universe of words alive. When you choose to stay, to subscribe, to leave a small light in the form of a comment, it's not just support for the channel. It's a gesture that says, you were here too. And that means more than I can ever say. I read every reflection. You leave every question, every quiet. Thank you. They remind me why I create, why I whisper these stories into the dark. Because somewhere out there, someone is listening. And together, we make the night a little less lonely. So if you'd like, tell me where you are listening from tonight. Your corner of the world, your starlit moment. I would love to know. Your words, your thoughts, your dreams, they guide me forward like constellations. From my heart, thank you for letting me share the universe with you. Thank you for being part of its story. And may your night be peaceful, your heart light, and your dreams full of stars. The universe remembers those who look up, and tonight, it remembers you.